streams, model building, and more. And that, right there, we are joined by the hero of science on this platform, Professor Danny Anduza. No, not the dinosaur!
But it's good to see you. It's funny, the audio cut out just as I clicked the join thing, and I think you got a raid simultaneously, so I hope I'm not jumping the gun.
No. We got a raid from N Simplex Pachinko, and he does math on his stream.
Very cool.
So we have, I was just saying how cool it is that we have so many different content creators from education, everything from paleontology, biology, math. Yeah, like, there's so much cool educational content here on the platform.
There definitely is, and it's, oh man, it makes me happy to see that.
It's,
so,
definitely growing.
Thank you for the raid, and good to see you, Bullet. How have you been? Congratulations, holy cow, on Partner Plus. That is really, really exciting.
Thank you. It has been, Danny, an insane 48 hours. So, we got Partner Plus.
Uh-huh.
We also got Throne Partner, which is the app.
I saw that on Twitter, yeah.
Yeah, that like lets people send items. Like, we got an accepted partner status for that.
Awesome.
Earlier today, I was on a unique stream. It is, we play the video game Grounded. So the developers have their own stream, Obsidian Entertainment, and I was on with them, and we were supposed to play the game, but instead we played for about an hour and a half and just talked genetics and behavior about the game, and people were like, there's science on Twitch, and it's like just this whole new crew getting excited for it.
Very cool, very cool.
And then we have this product line coming out on Friday. So we don't own the products, but we did this consulting for Star Wars STEM toys. And that is dropping this week in Target, Walmart, and on the back of the box it said, Science by Science Media.
Awesome! Holy cow!
So we're doing a special.
Is pretty exciting.
Yeah, we're doing an unboxing and a special stream on Saturday for Star Wars Day to show off the items, and so it's been like a wild 48 hours.
That is incredible! Congratulations! That's so exciting.
Thank you. Yeah, so that's why, Danny, I wasn't able to be first in your stream today, because I was on the Grounded folks, and so I had you tabbed up. But I wasn't able to grab the first today.
Yeah.
How was your stream today? And happy birthday to your dad.
Yeah, thanks. I actually I went to go see my dad this morning and showed him around a fossil site here in the Bay Area, and yeah, we might have some news about that coming up soon. I can't reveal much yet, but there's a non-zero chance we'll actually be streaming from there before the end of the month. So
nice.
We'll see about that.
This is to your local area too, so it's like pretty close. Oh, nice.
Yeah.
That's super cool.
Definitely. Yeah. And yeah, things have been good. Things have been busy. Really excited to be leaving for the field and be, it's less than a month from now. Holy cow, it's really sneaking up. So I'm excited. It'll probably be around like the 25th or so.
Nice.
Probably that I'll leave for Salt Lake, do some categorizing and labeling all of the different items that were purchased off the wish list, getting those packed up, and then going up to Wyoming to go do our digging.
And that wish list, y'all, we have pinned to the top of the chat. That is an Amazon wish list that you can help Danny out in the field, like stuff that's going to be used live in the field. And like, there's a ton of stuff gone, but there's still a couple of things left as well.
Ethan actually just texted me about that. What did he say? He says, I won't be adding anything else to the list. We are set equipment-wise, literally for years. Vehicles aside, we're as well equipped now as some of the biggest field programs in the country. He is blown away by the generosity of this community. It's been incredible. So if anybody wants to scoop up one of the last of those items, they're going to be gone soon, and it will not be refilled after this, it seems. So.
And a cool part, right, is that you can email dinosaurcampaign@gmail. Hi, Evermore. And if you do that, you will have a label maker with your name put onto the item. And so you can see your thing in the field being used. And not just this trip. but like as Danny said, many trips to come. Like the lights don't go out of fashion, right? You still will need lights and pencils for notes, not for fancy measuring stuff, as I thought.
Yeah. So, yeah, we're really really excited. This is going to be an awesome summer. And I just tested out the satellite dish that's still working. The router's still working. Firmware is updated. We're all set.
And that's a great aside for me to show off your YouTube page, because if anyone's looking forward to like what you're gonna be finding and seeing, y'all, this is life-changing stuff. Like this is what is gonna inspire the next generation of kid to become a scientist. Is this YouTube page right here with all the VODs? Check out the live streaming from the field, asking questions from a paleontologist in the field. Y'all, there's nothing like it. It's so freaking cool. And museum tours and past VODs, like please check out the YouTube as well.
It's going to be a pretty unique opportunity to be able to do outreach, live from a dinosaur dig. We did it last year. It's going to be even bigger this year. Very, very excited about that. What a privilege to be able to do this kind of outreach. It's only because of the generosity of this community that this is possible. So thank you for making this possible, everybody. Holy cow. I
didn't realize you were telling this story earlier, I guess this week, about fossil smugglers, and that you had folks coming by and asking if that you had seen any suspicious activity.
Officers from the Bureau of Land Management who came to our quarry last year, and they asked us if we'd seen any suspicious any fossil smugglers or poachers or anybody like that. And they told us that they were in the midst of a big investigation. And they're like, yeah, just keep an eye out. Look at the headlines. Sometime in the fall, this will probably break. And it did. It was wild stuff. Should I give you a link? I can probably find that real quick.
Did they find them?
Oh, yeah.
You said they were trying to smuggle it to China or something, right?
Yep. Yeah. Let's see. Here we go, from NBCnews.com. Let me go to the chat. There we go. Yeah.
Oh, wow. Yep, there it is.
Yeah.
It's a shame that it still happens,
Oh, yeah. No, that's the thing, is that a lot of the government agencies that are in charge of overseeing this, they're extraordinarily understaffed, underfunded. I think there's like a handful, it might be like 2 or 3 different Bureau of Land Management officials for the entire state of Utah. It's nuts. But
wow, that's ridiculous.
That they're still able to protect fossils like this to the extent that they were. So.
And yeah. I don't know if this is just my naive eye, but this seems like a pretty unique looking piece.
Oh, so that one right there is carved. That's just a dinosaur form that has been carved to make it more attractive to a potential buyer.
Oh, okay. So they're not only taking them from the land.
They're defacing them too. Yeah.
Oof.
Yeah.
Yikes.
Yeah.
That
sort of thing's really common in Utah. Like, we have to make sure that our sites are, when we leave for the summer, we have to bury everything really well so that we don't have vandals showing up and just destroying everything.
That's when you're leaving, right?
Yeah.
Wow.
Summer. So.
Because you know where they are.
Yeah.
Yeah, because it's marked, and it's just.
It creates a lot of extra work for us to have to, remove all of the rock that we put on top of the site. It takes a couple days usually to get back down to the bone layer, and that's what you got to do, or else vandals will come in and just destroy everything. Yeah.
That's such a shame. Like, I didn't realize it was such an issue where it's like you have to be accounting for those kinds of extra things.
Yep. Yeah. Even if you just leave for a weekend and leave a fossil jacket there that you haven't flipped and pulled out, sometimes you'll come back and it'll just be completely destroyed by somebody who just decided, oh, that's a weird looking thing, let's break it. This impulse that people have, grown adults,
Like, it's clearly not there by accident, right? Like, it's clearly there because there's a purpose to it, and people just decide that.
Yep.
Oh, I'm so sorry. Because that's also just, on top of the work that you have to do to dig up the bones. If you go back the next season, which, sometimes you've told us, like, if it's a really good site, there's no reason not to. You have to, it's not like you're starting from, like, an advantage point, because you have to rebury everything.
And sometimes we have to leave things there over the winter because we don't have an excavation permit. So you can't pull all the bones out. You have to leave them there because we have to apply for permits and make sure that we're doing everything legally.
Yeah.
But, vandals don't care about permits. They'll just go and smash everything up if they find it. So it happens. Yeah.
Is there, and this is a naive question, I don't know if you know this, but is there a lot of money in this kind of trade? Like, is it something that's really, like, if someone's really desperate, you're pulling in enough money, or is this something where it's, like, really financially not even worth something, like a devastation?
It's really not even worth it.
Okay.
Like, so, in this particular case, I think these people were also involved with meth and stuff like that, and, yeah.
Gotcha.
People think of it as, like, a quick buck, like, it'll be easy to dig up these dinosaur fossils and then sell them to a pawn shop or something. Yeah, apparently there have been dinosaur fossils on some of those pawn shop reality TV shows.
Yeah.
And that has honestly done a lot of damage to dinosaur
Well, so
mythology.
that is illegal, right? Like, if you look at the letter of the law, they're selling contraband.
It depends. So if dinosaur fossils are found in the United States on private land,
Mm-hmm.
you can do whatever you want with them.
Okay.
They're the property of the private landowner. There's no laws that are protecting this, scientifically important fossils in the U.S. unless they come from public land.
I see.
In which case, they belong to all of us. They belong to the people of the United States collectively, and they belong in a museum. But on private land, anything goes. Yeah.
So it's one of those instances where seeing it on a pawn shop TV show,
Yeah.
presumably you can't prove if it's from public or private land. And so all you're seeing is this bidding war happening, and it's almost encouraging people to go deface and steal because of the show makes it sensationalized to make a buck.
Yeah, exactly. It's treating dinosaur fossils like they're a commodity rather than scientific specimens that need to be studied and protected.
I like when you told us about the story about The Rock, who 3D printed, right?
Oh, he had a cast, so like a
the cast made
cast replica of Stan the T-Rex. Yeah.
Yeah, it's like that. It's like that makes sense because then the money's probably going to something worthwhile, and then you have your dinosaur, but the scientifically valuable specimens get to stay with the researchers, the museums, and
exactly.
But I know it's hard, but thank you for telling us about these kinds of things. 'Cause I think it's something that most people, at least in our communities, wouldn't think about. Because why would you destroy a specimen, right? Or steal specimens? And it's just
do that. Yeah. So a big part of fighting against that is just getting the word out, being like, these things are important scientific specimens. They belong in museums. They should be studied and enjoyed by the general public. They don't belong on your mantelpiece back home. They don't belong in your garage.
Yeah.
Be considerate of the science.
Yeah, absolutely. And more if possible, because it's never really done enough.
Exactly.
Speaking of Tyrannosaurids, then.
Yeah.
Shall we get into this paper, Danny?
Should we do that one, or should we do the neurology one that you had? Because I feel like that's a nice kind of tie-in there.
I feel like we have to do the
Drosophila neurology, or
I think we have to do the dinosaur one first.
All right.
I don't know about you. I know you talked some about this on your stream last week.
Yeah.
But man, there's just thoughts. There's thoughts here.
Did you look at the original paper? I'm really eager to get your viewpoint as someone who's dabbled in neurology to the extent that you have. You know a lot more about that than I do, certainly. Holy cow.
And I actually have a bunch of papers as well that I thought would be side interesting for our chat today. Would you actually? I'm so sorry to ask this, Danny. Would you be able to turn up your mic a little bit? I know it seems like it's the usual cranking that we do, which is then unfortunate because I know it's a different audio level for the rest of your stuff.
Is that better? Let me know.
Chad, is that better?
What do you think? I'll just try and remember to reset it so I don't blow out everybody's ears when I start my stream tomorrow.
Exactly. Hi, everybody.
Yeah.
Woo! Okay, everyone's like, it's way better. Okay, cool. Awesome.
Nice. Okay, cool.
Thank y'all for the feedback. Guest Star, remember, is still in beta, so sometimes, I can't see on the bar, so you have to give me the feedback. So thank y'all for letting us know when things like that is happening. Okay, so this is the original paper. And Danny, do you want to? I have the video too. Whenever we want to touch on it, but do you want to set the stage for us? Because you're like, I would love to take I heard your opinion on your stream, but
yeah, and I've had more time to think about this too after reading the rebuttal paper today, and they didn't really say it in the rebuttal, but as dinosaur paleontologists, sometimes we're, let's say, annoyed when people from other fields of science decide that, oh, well, dinosaurs are really cool, but they're not what I work on. But, dinosaur science, this stuff isn't, brain surgery. I'm sure I understand this. Let me publish on something that's outside my realm of expertise, and I'll get a bunch of attention for it. And this kind of feels like one of those instances where a scientist who does not study dinosaurs decided to publish a dinosaur paper without really understanding dinosaurs or having really even had any co-authors who work on that. So this was a single authorship paper, wasn't it?
Yeah, so single author, and it's the Department of Psychology, co-appointment with the Department of Biological Sciences and the Brain Institute. So this is... I read a little bit into the creds, and it's much more of, oh my goodness, a gift sub to stay in your lane.
Octavius, that's brilliant. Yeah.
Thank you, Octavius. And to be clear, Danny and I having a chuckle. I don't think either of us would be gatekeeping of other scientists coming in. We wouldn't be having this collab if we thought that. But it's one of...
That's the thing, is it should have been collaborative. Instead, this was like somebody who's not part of this field being like, dinosaurs are easy peasy. Let me just publish a paper by myself about this. It's like, no, bring some people who actually work on dinosaurs in and collaborate with them. That's not what happened.
Exactly. And it does seem like where, again, that their background isn't necessarily suited for this. And I actually... Yeah. So the title I think is also misleading, right? For a lot of different reasons. Because it's dinosaurs having primate-like number of neurons, of certain kinds of neurons in the brain. To me, as a non-dinosaur expert, even if I pull back working on neuroscience, to me this reads as dinosaurs are as smart as apes.
That was the implication.
Yeah, right.
It is. Yeah, it's not just this is a clickbait headline or whatever. It's no, that's actually that's what she applies in the paper, yeah.
And, so what got me, Danny, is I read this, and I did a literature search just to see what has been done on neurons of birds and primates. Because that's, right, one of the things that you're going to be able to look at is, presumably a model of of brain composition in birds and kind of tracking back to the troodontids and maybe going back in evolutionary time like that, right? Sure. And a literature search of papers that had been out at the time of this paper being published suggests that this is already malarkey, to put it kindly.
Yeah.
So this here, this is not a dinosaur paper that I found, but its avian neurons consume 3 times less glucose than mammalian neurons, is the title of this one. And this one suggests that there is a difference in efficacy of how efficient neurons are in brains of birds versus mammals. So this is a younger paper than that paper that came out. Right? And so it's already, to me, saying that this kind of comparison in modern animals that are alive might not be valid.
I do feel like she kind of addresses that a little bit in the paper, to be fair to the author of the 2023 paper. she talks about how like bird brains are more efficient than mammal brains. How they, they might be proportionally smaller, but they have more neurons packed into there, and they're more efficient in their resource requirements and stuff like that too. But there's a lot of assumptions that are made in weird ways that don't track. And we can get into that in a little bit, but
yeah. So that was an interesting part too of like just right these assumptions that you're making when you're writing this paper about like what the composition of the brain is. Like you said that in this paper it was like, well, birds can fit in more neurons, right? But there's actually papers. This is, in her defense, this is a brand new one that I actually it came out. Well, actually, no, it's not brand new. Apologies. This is June 22. So this is.
Oh, okay. This is before her paper. Yeah.
This is before the paper dropped. This is modeling neuronal total number across brain structure in mammals, birds, and crocodilians. So it seems like very pertinent. When I found it on a bioRxiv paper.
It wasn't cited?
This was not cited. And this one demonstrated that number that was put into the paper of like birds having more is not correct.
Oh, really?
It's correct insofar as birds and mammals have more neurons than crocodilians. But that birds having more neurons than mammals is not a set number. There are some where it is and some where it's not, and so
that makes
like
a lot of sense.
And it's they didn't in this one. It's much more like they looked at a bunch of different components, but it's not a set number like as a function of whatever they're looking at. Like it's variable, right? And so I think if you're building it into a model, that's a hard thing to build into it. And so this is again just a quick literature search that I was looking and reading on these like couple of extra papers about looking at efficiency of the neurons that I thought was important, or this one too, which was 2016, that was cited in the paper, but it was actually miscited. So in the paper, this said that birds have a comparable number of neurons to primates as based on past literature. But this was the past literature, and it was only looking at the forebrain.
Okay.
And so it's like some of the data doesn't quite add up in terms of the model that's being built too. And so I think that makes it a little bit difficult to be going back and forth, like in these different points, if that makes sense.
It does, yeah, and that seems to be kind of a common thread with this paper, honestly. There's a lot of stuff that just it doesn't actually follow. There's like weird assumptions being made.
And it's not like it's not cool. Like just to be clear,
it's a really cool paper, and it's an interesting way to try and think about it, but it's like it's missing a lot of the context and perspective that having co-authors who deal with dinosaurs would have been able to give you. So I don't know. If there's one lesson that comes out of discussing this paper today, I bet you it's going to be collaborate with co-authors who have expertise in areas that you have blind spots in. Like science is a collaborative process. It shouldn't just be I'm going to publish this paper as a single authorship, as a single author, and then assume that I know everything, because it doesn't go well.
The other thing too is neuronal populations, I thought, was an interesting subdivision. So actually in both the papers it made it almost read as if there were only the neurons were important.
Oh yeah.
And the only reason I point this out is because at least in insect learning and memory, there's also glial cells that are also important.
Right,
and the glial cells we know can also function to inform learning and memory paradigms in other creatures. And it's one of those when you take the brain of an organism, you can get the raw number of cells, and that's probably what they're doing here, right? Like of citing data where it's like, actually there's this really nice figure in the new paper which has the collaborators of like the breakdown in the brain regions.
Yep.
Here we go. Let's see this one right here.
That is a neat figure.
Yeah, so they've got like the cord, the brain, the bulb, and yeah, Dame Karen. This I'll post a link for the paper in just a sec, Dame Karen. This is the new one that we'll be chatting about. I'll post the old one as well. But so as they're sectioning like these different components of the brains, you can actually there's a really cool test. You can get this massive tissue, and you basically get a mortar and pestle, not as crude, but essentially the same concept, with some detergent and some other liquids, and it'll separate out the cells. It'll get rid of that matrix, separate everything out, and then there's a machine where you put your solution into, like of now this cell, and you give it a threshold. You say anything that's bigger than this size is counted as a cell. And so what you get out of the end of that is a raw number of cells that you're dealing with. And it's a really cool device, but it doesn't subset on glia or neurons, and so both can do different functions and sometimes overlap. And so that resolution we don't quite have, and I think if I could have done anything differently in this paper is to try to figure out an estimate for glia as well, because that is, I think, a more and more recognized cell type that is important in cognition, in memory maintenance and clearing, as well as just overall brain maintenance and health of the brain.
Interesting.
So but I thought it was, it's super cool that we have this nice figure to go on of like the segmentation of this, which wasn't in the other paper. So as Dame Karen pointed out, like, well, how does one know if one paper is good and one paper is bad, like in terms of like the data, right? And so I think for this, if you read these two, both are peer reviewed, right? Both are in a published journal. It's one's evidence, I think, for me going in as a skeptic, it's more conclusive. Like there are more lines of data to suggest that this model is correct versus the other one has gaps, not just in what's cited, but also it feels like there's some maybe logical gaps in there.
Definitely. Yeah, and the thing is, in the 2023 paper, the single authorship paper, the author, she's trying to use neuron counts as a proxy for all of these other different things, like using it as a proxy for metabolism. So, like, which of these animals were warm-blooded or cold-blooded versus the number of neurons that they have there. And it doesn't work that way. Like, we have got lots of different ways of trying to determine metabolism. You can't just use neuron count as a catch-all for all these different things. Like, it's ignoring all of these other lines of evidence that we have and trying to use neuron count as like a magic bullet there. It doesn't work that way.
I think it's even more by that current bio paper from a minute ago, where it's like the glucose use, right, is fundamentally different between the organism that you're looking at. Like, I know it's like bird versus mammal, so it's very broad, but let's say that statement holds true, then definitely number of neurons does not equate to metabolomic load, because there's a difference in the organism. And
absolutely, yeah.
And that's I wanted to ask you too of like what you thought about that when looking at this data. How does one infer what a dinosaur is closest to, right? Or what dinosaur to look at? Like, I would be more comfortable if it was a Troodon, which is closer to the bird relatives that we have, right? Versus something a little bit further back in evolutionary time. What
a Tyrannosaur.
And which is what they did. What do you think, as the scientist here who's the expert, what do you think is appropriate in terms of evolutionary time to look at?
So I think all of them are appropriate to look at. Like, it's cool to examine, to try and come up with like an EQ for any of these animals, encephalization quotient, like the size of the brain compared to the overall mass of the body.
Yeah.
But if we're trying to use birds as a proxy for dinosaurs, it pays to look at the dinosaurs that are closest to birds, like Troodontids. But the thing is, we don't actually have endocasts of most dinosaurs. Endocasts are that's the inside of the brain case. So like the internal shape of the brain case can give you a clue for what the dinosaur's brain looked like. We only have that for like maybe 40 different dinosaurs that have ever been named. And so I think they looked at 31 different dinosaurs for the rebuttal paper here.
Yeah.
Which is a good number. I didn't actually know there were that many, and then I started thinking about it. It's probably about 40 that we have in Endocast. So,
is it just difficult to fossilize, or is it like what is the limiting factor?
Like, in order to actually have an endocast, you have to have a complete brain case. That's pretty rare to be able to have all of the bones that enclose the brain. It's tricky to find all of those, and then you have to find a way to actually determine the inside of the cavity in there, like the shape of the inside of the brain case. And so that used to be really, really difficult before CT scanning. Nowadays, you can just stick it in a CT scanner and then have a beautiful digital picture of the inside of the brain case. Yeah, but even so, like having a dinosaur skull that's complete enough to have the whole brain case, and then you can get that and put it into a CT scanner, it's just not been done very many times.
We have a question from Smikes Danny. How many dinosaur species are there with like that? With comparing to that 40, and he says, "I know dinosaur number is squishy from last week for the species."
Yeah, so there have been about 2,000 different dinosaur species that have been named. Probably fewer than half of those are valid. Meaning they're actually, a lot of those are duplicates. The same dinosaur got named twice. You know, one's an adult, one's a juvenile. They're actually the same thing, even though they were named two different species. Stuff like that. And a lot of other dinosaurs that have been named are based on really, really fragmentary material. And so, yeah, the dinosaurs that we've got good evidence for, there's probably about, I would guess, like 800 genera. If that, it gets squishy, like you said.
So that, but the point holds that 40 is minuscule to the whole number of dinosaurs that we've got. So it's like the likelihood of it being preserved is already super low, and then it's cool now that we can use CT scanning to get that inside component, and it because like how otherwise you'd have to cut it open, right, and presumably some of those bones will get damaged from that kind of cut as a function of just like the bone itself, not because of the person doing it, just because it's a fragile bone.
Yeah. And to be clear also, there are a bunch of different dinosaur skulls that have never been scanned. Ones that exist, but nobody's done a CT scan of, I would guess, like the holotype skull, or the skull of Scelidosaurus harrisoni from the UK. I don't think anybody's ever done histo on that and looked at the shape of the brain and everything. Even though we've got a beautiful dinosaur skull there, I don't think anybody's actually done that. I could be wrong. It could be here in the paper. If it's going to be anywhere, it's going to be here in the paper.
If there wasn't one done, what is your suspicion of like why? Is it just like
it's just there's not enough paleontologists and not enough funding for this kind of thing. You know, there are thousands, millions of fossils that exist in museums that have never been studied or published on. We need more funding. We need more people to work on these things.
So this isn't a hesitancy like taking like the histo samples like we talked about. Scanning, no. Okay, because you're not damaging
also, it. Especially here in the United States too. Like CT scanning is obscenely expensive if it's done for medical purposes.
That's Smike said that if the dino couldn't get insurance to cover it too. So
yeah. When I was in Bozeman, Montana, working with Museum of the Rockies, occasionally we were able to bring fossils up the hill to Bozeman Deaconess Hospital and use their CT scanner, which is kind of cool because they, the radiotechs or whatever you call it, people who specialize in this and doing the CT scans, they were like thrilled every time we were there because it's like, oh, cool, we get to scan a dinosaur today. That's pretty interesting and cool.
That's really cool, yeah.
Yeah, so we had a good relationship with them, and they didn't charge us for it.
Nice. But I imagine the charge, like you said, is, well, it's like an hour of time, right, as well, at minimum, I'd assume, because that's how much it is for a patient, and then that's not having a patient be seen, so the lost revenue to make, I bet it adds up pretty quickly.
Yeah. So, but normally we would get in there if they would have, like, they thought they would have an opening in a given week, but sometimes that would fill up.
Yeah.
So we'd have to come back the next week, stuff like that. Yeah.
Do you get the radiograph files, like, or do they read it for you, or do you get those?
So we would get like a digital file.
Okay.
I think normally they put it in a Dropbox and you can download it.
Oh, cool. Okay. Nice.
Yeah.
I don't know if you had to wait for the radiologist to read it for y'all to.
No, definitely not. Yeah.
Neil has I think, an important question, like bringing us back to the paper, of what is the goal of the paper? So is it to compare intelligence of dinosaurs compared to mammals by comparing neuron number or density in birds, or are we missing the point of the paper?
Maybe we should pull up the video. But basically, it was kind of like a gee whiz paper, like, oh, T-Rex would have been so intelligent because it would have had neuron counts similar to baboons or macaques. So they must have been, how cool were T-Rex? They were also super smart. And the author did that, and also trying to determine things like the metabolism of different groups of dinosaur based on their estimated neuron counts. But neuron count is not a good proxy for metabolism, and she didn't really have good estimates of the neuron counts anyway. So that's kind of where it falls down.
So I guess that was like we'll watch the video, but like in reading the paper, that was a goal of like, how can I demonstrate intelligence? Which I think we talked about this a few weeks ago too. What is animal intelligence, just as an overall more philosophical question, right? Because that can qualify as, I think the way we explained it was like an insect intelligence. Like you're like, well, a bug is really dumb, but it's like, well, is it dumb, or is it smart for what it needs to be smart for?
Yeah, I talked about this. Was it yesterday on stream? We were talking about this, where like, if you were to have a conversation somehow with a woodpecker, which are not regarded as some of the most intelligent animals, you'd be like, well, you're just pecking at trees all day and eating bugs, like, you can't be very smart. And the woodpecker might turn around and go, well, shoot, you can't even fly. Look at you walking around on your dumb mammal legs on the ground, and like, you can't remember where you put 4,000 different acorns, or like, you can't navigate during an annual migration over thousands of miles. Like, you need Google Maps to get around. How dumb are you?
Right.
Different animals are.
That's a very good example. I love that. Actually, that's a great example, Dan. Yeah, it's like you need Google Maps versus the bird just has like instinct. Like, what's wrong with you? That's a very, very good example. I really, really like that. Nice. We had Sloppy says, I think the thing that upset me most about the paper was the reception by the unprofessional dinosaur YouTuber leaping on the paper, making fun of the use term of culture. See, Sloppy, I can see the other direction too. Is if like yes, you can criticize and critique the term culture and say that's like, oh, haha, dinos wouldn't have it, but you can also put it in the opposite direction, where this can be like a leap of a knowledge gap, where it's not that I think that dinosaurs absolutely could have had culture. Like there's arguments that fruit flies have culture, right? There's no reason why an animal can't transmit information, not genetically, but by learning socially, if that's how we define culture, right? But
there's a paper that I'm working on right now for publication, and we talk about how fishing behavior in grizzly bears is cultural. It's not instinctual. It's a learned behavior passed on from generation to generation. That's culture.
Yeah, and it's a squishy term, culture, but it's like the really good papers at the beginning of the paper like lay out what they are defining as culture. Like, here, this is what culture means. This is how we observe it. This is how it applies to our paper, and here's how we fit the definitions with our own criteria of what culture means. And I think like that's the clean way of doing it. And so Sloppy, I guess, they can do in the opposite direction as well, where if you have a paper where dinosaurs are as smart as monkeys, right, someone might start like jumping ahead of things as well on that front too. And it's like, it's always a balancing act. There was a paper we talked about, Danny, a long time ago now, many months, I guess. There was controversy. It was published, I don't remember, maybe it was in Cell, and it was attempting to argue that race does not dictate intelligence.
Sure, yeah.
Which is it's a very good argument, and they showed it. Like, they were like, we did genetic sequencing, and sure enough, there was no relationship between the two, but there was a figure where it was broken down as this construct, and if you looked at it, and you did not read the rest of the paper, you would come to the opposite conclusion. And the fear was that this would be a lightning rod for people arguing that, there's these intellectual differences where there aren't. And so there was the argument of, well, should this paper be taken down? Should it be maintained? And it was like a lot of back and forth on that front. And so even a good intentioned paper can have these like very negative throwback consequences. And I think, Sloppy, that would be one worry too, of like if you're making these arguments of like the dinosaur intelligence and equating it to apes, there could be a misinformation jump there as well, like in either direction, I think. And so it's like you said, Danny, having more experts backing up your claims and like having more lines of data is only a good thing in this situation.
Yeah, it's, I don't know, this is I'm not saying that like, oh, people should stick to their individual disciplines, but like if you're gonna publish across disciplines, get some people who are co-authors that, who are actually trained in these areas. And I don't know, when we watch the video here, I don't want to be too cynical about this and be like, this paper was done primarily just to get attention and to be able to get press and everything. But I don't know. Maybe we should just watch it.
Well, I guess independent of this paper, that does happen. Like, that is a thing in our fields, right? And so it's... Yeah. I know sometimes Chad will be like, no, scientists wouldn't do that. But sometimes it's the weird thing that does happen.
Yeah. If a paper is not particularly good, but it gets a lot of attention, it might be that, like, the purpose of that paper was mostly to get attention rather than to really drive the science forward.
I mean, we had one like that. Not we as in published, but like there was an ant paper, like a year and a half ago now, and the headlines were "Ants smell cancer." And the headlines made it seem like a modern medicine revolution was taking place.
Right.
When that wasn't at all. If you read like the paper, it was like wholly blown out of proportion. Even the university's press office was blowing it out of proportion. So it kind of made you feel like someone wanted it just to blow up for the sake of conversation and not necessarily for the actual science behind it.
Yep, and it's hard not to get that impression with this paper and with this video. Like, I think it's really, really cool to have a video that accompanies a new published paper as a way to, give news agencies an opportunity to like talk about your work. If you provide video content that goes with the paper, you're much more likely to get good press for it. And here they had like a professional firm that came in to produce this video. It's like production quality is very, very high, but I don't know. That's almost a red flag in this particular case. I don't know.
I agree with you. I think it can be a game changer if you have the opportunity to make your science more accessible to more people through an accessible video where you get to talk to the scientist who did it and you show the work, or even show in the lab, like, here is the dish that I run stuff in. Even if it's just something like, here is where I keep the bugs. Like, I think I don't know what it looks like for a wasp lab and how they keep like paper wasps alive. Like, that's cool. Like, and I'm in the field, right? Like,
it helps tell that story too, and it's kind of a show don't tell sort of a thing where it's like, let me invite you into the laboratory. Here's how it works. Let me, walk you through the process so that you can understand it better. That's different from just like somebody sitting in front of a camera and explaining it. And that's kind of what we have here.
Yeah. Shall we?
Yeah. Let's do it.
It is beautiful just already, by the way.
Really well shot. Like, professionally done. Yeah.
Also, just like the placement too of like the dinosaur figurines and like all the it's really pretty. It is really, really pretty.
You do kind of have to wonder like how many of these objects were brought by the video production people. Like, it doesn't feel, it feels contrived is what I'm saying, I guess. It doesn't feel like this is actually her laboratory or It feels like it's all kind of for show.
Oh, it feels like
maybe that's me being overly cynical. Maybe her office really does look like this. Maybe it is dimly lit and she has like a Lego brain there. All this stuff. Maybe, I don't know, but it feels contrived.
I've never seen an office like this, and I'm getting vibes of Jurassic Park. like in the movie they have like this whole like Professor Hammond like talking of Welcome to Jurassic Park and like an intro video, like when they're going through the cars. That remember you switched out to your face and you explaining of all the. It feels a little like that already. Spooky Moth. Thank you for the resub, Spooky Moth. It's Mothgoth. Change username. Swing through.
_ just subscribed for 23 months. Hi, it's Mothgoth. Just changed the username. Swinging through to say hi.
Spooky Moth, thank you for saying hi, for the resub, and for being a bestie, Theo. It's great to see you. I hope all is going well. Thank you for that resub and that piece of raw science. All right.
What if I could tell you how many neurons you would have found in the brain of T-Rex, the royal tyrant lizard who reigned pretty much unchallenged until an asteroid hit the Earth 65 million years ago? You would probably
Hang on, pause it right there. So, this was published in 2023, which is like 10 years after we had revised dates for the KPG boundary. We've known for like 10 years now, at least, that it was 66 million years ago and not 65. And if you're going to be talking about Tyrannosaurus and you're getting the date that wrong like that, I don't know, it just kind of, you're not painting a good picture of your own expertise if you're doing that kind of thing, I guess, you know?
I think it's one of those things where, and this I think maybe illustrates your point too, where the non-experts, I found out that it was 66 from you.
Yeah.
Because like it was in 7th grade, we had a bonus question on the end of every test. When did the dinosaurs go extinct? It was the same bonus question every test. You put 65 million years ago, you got a point. And so I guess I would have been in college and I didn't take any course that was about dinosaurs, but yeah, it was never a revised number. Obviously, someone in the field like you would have known that the moment something like that would have come out. But maybe that's another example of having someone who's not just in the literature or like vaguely about the neurons, but is like aware of the literature. Because I think that's an important part of it, where if you're demonstrating knowledge about this, you have to be up to date on the literature.
Exactly.
And so it's not, so like Dame Karen, it's not that she's casually talking about dinosaurs right now and we're criticizing someone who's casually talking about this, but if they publish, it's like she published on a dinosaur, and knowing the extinction time is important for the data. And if you are writing the paper, you have to have the most up-to-date literature, like citations in the paper, where it is, I think it's fundamentally important to have, because you're painting the picture of what we know now. And if you're citing things that are wholly out of date, that is a poor reflection on the upcoming data for the rest of your paper. Even if the rest of your paper is great, it doesn't frame it correctly because you're not talking about what you already know versus what is already known. So it's not that she is a non-expert who's talking about this. It's that, well, it might be that she's a non-expert presenting as an expert, missing crucial facts. Is that a probably the right way to say it, Danny?
I would agree with that, and I would maybe add on to that as a dinosaur paleontologist, as somebody who works on dinosaurs, maybe it's that I have a little bit of a chip on my shoulder, but I feel like other scientists in other fields would be like, oh, that's fun science, or that's kid science, or something like that. Like, dinosaur science is popular science. Like, can't be that complicated. Let me, as a neurologist, publish a paper on this. I'm not going to consult with any dinosaur people, but how hard can it be? Paleontology is easy, I can do this. It's like, I'm kind of getting that sense. from this paper and frankly from this video.
I want to highlight.
Maybe I'm wrong, but yeah.
Well, something that's important that you tell us every stream, and I think it's not known very well, is that you are a paleontologist who works on dinosaurs, but that's not most paleontologists.
No, we're dinosaur paleontologists are definitely in the minority among paleontologists. Paleontology is just the study of fossils. That's everything from, fossil fungi to pterosaurs, from bacteria to baleen whales, from fossil plants to, dinosaurs. And there's a living thing that lived on our planet, left record of its existence in the rock record. There's a paleontologist who studies that.
We had one at Dartmouth, Danny. And so my point is, I didn't know that it wasn't dinosaurs. I was in the naivete of that. And so there was a guy who was teaching a 3-week course that we had to take, and he was labeled as a paleontologist up at Dartmouth. And I was like, oh God, we're going to learn about dinosaurs. I'm so excited. And it was just looking at sequencing data.
Yeah.
But that's it. Phylogenetic trees. And I was like, where are the bones? Can we see your lab? Because I'm like, oh, what does the lab look like? Are there bones?
There are paleontologists who never touch a fossil, during all their work. Paleontology is just the study of ancient life, usually through fossils, but sometimes you can work based on the work of other people who are actually touching the fossils,
And so he never, the lab was computers. And that's it?
Yeah.
And it was, right, and so it's just kind of, it might be one of those things too, and maybe there's that naivete here as well, of this is what a paleontologist is. Maybe I don't have anyone at the uni who works on dinos, or maybe they find someone and it's like the phylogenetics guy who wouldn't be the one. I would guarantee you that phylogenetics guy did not know 66 versus 65 million years, because that just wasn't the point of what he was looking at. And so it might be one of those situations too, where maybe there were consultants on the paper, not necessarily co-authors, but you're not picking the right people again, because they're not the experts on it.
If you're going to be publishing on theropod dinosaurs, then you should have somebody who works on theropod dinosaurs as an author on the paper, or at least it should have gone out for review at the very least to somebody who works on theropods, because this wouldn't have made it to review, I don't think.
That's what I was going to ask you, and kind of getting back to one of the chat's questions earlier about it being peer-reviewed, and because it's anonymous, we don't know who peer-reviewed it or how many even peer reviewers there were. But
it's in a neurology journal, right? What is the journal for this?
This is the Journal of Comparative Neurology. Oh yeah.
Right. So I don't think they would have consulted they probably didn't have a dinosaur person to reach out to be like, hey, can you review this paper? It's probably other people doing comparative neurology, and they're like, yeah, sure, looks good to me.
Yeah, that's a really good point.
Yeah. Thanks.
No. I guess I'm disappointed.
Yeah.
It's a disappointed point of, because in my mind I'm like, well, you have dinosaurs in the paper. Surely you'll suggest that for someone, or you'll have that as a suggested reviewer, or the editor will think we need to find someone. And as you're saying, well, it's probably not even admissions. That was not a good point. As in, Danny, I'm not all in. I was just
I know. Yeah.
Disappointed. Oh yeah, you're right.
Yep. Yeah, which is disappointing for a paper that's getting a lot of press like this. People who got a lot of press. I think that was the point of the paper, was to get a lot of press. And have a pay for a video like this to be produced too. But it's just frustrating when it seems like somebody's publishing a paper for attention rather than to actually drive the field forward. Come up with new ideas and collaborate with other scientists and try and figure out what's really going on. This kind of felt more ego driven, honestly. And maybe I'm wrong about that. Maybe that's, I don't know. Maybe that's a misinterpretation, but I get that feeling kind of looking at this video,
When you submit a paper, and I was checking to see if this is the same in paleontology, you can suggest reviewers and you can ask for reviewers to be excluded, right? would you
Well, certain journals don't allow you to do that, but
Okay.
most of them do. Yeah.
Okay. So, and Dame Karen, people do not offer to be reviewers. There is not a list of people to be reviewers. You can suggest someone, and then otherwise you are cold emailed.
Yep.
There is no financial compensation. It is expression
Ideally-
of goodwill.
Yeah. It's something we do for free. You know, we're basically doing the work of the journal for free. Yeah, I guess it kind of stems from a time when, like, it was understood that people are salaried and they've got, like, a well-paying, you know, tenured position at a university, and, you know, like, oh yeah, they've got time to, you know, do an active community service like this because the university's paying them. That's probably like 60-70% of the time now. That's not the case. It's yeah.
I get daily emails, and half the time it's from a predatory journal, which I would argue almost pretty much all of them are. But like it's, you know, it's like here. Oh, their newest thing is they give you a plublon, as they call it. I don't know if you've been offered this, Danny. A plublon.
No.
It is and it's not just the predatory ones. This is like I did a review for Current Biology, and they gave you a plublon. It's this token, this digital token that like you collect of how many like reviews you've done, and the more
Does it have a cartoon monkey on it? Oh, journal NFT.
Actually, hold on. I wonder if I still have it.
Yeah.
All right, there it is. Yes, I have it. So there is this bioinformatics journal that I reviewed for once, and you got this sticker. Okay.
Okay.
And it's called the Open Access Wackaloon.
It's a lovely loon there. I like that. It's got a talent.
And the reason for this is because the editor-in-chief was called a shrill, and that he was he was, as an insult, someone was like, I hate that you're all about this open access, and that you are just a wackaloon. And so and so he had it commissioned, and all the if you review something for this paper, you get these stickers. And so
that's cool. That's cool.
Yeah. No poublons,
Some kind
though.
of a reward.
No poublons.
There is a thing with some of the open access journals. I don't know if they still do this, but I want to say that Lost One and PeerJ used to do this, where you would get your submission fee waived if you reviewed a certain number of papers per year, or you could. There was a thing too. Oh, nice.
Copy Zombie. What a nice name. Thank you for that resub. Welcome in, Copy Zombie. A piece of raw science. Welcome.
Nice.
So you would get it waived, really?
Waived or reduced. I don't know if they still do this, but I want to say that when PeerJ was fairly new, they used to do this.
Okay.
And also, you could purchase like membership, where you agreed to basically review 2 or 3 papers a year or something like that, and then you could have a paper submitted for like $500 or something like that.
Mm-hmm.
So it's like super reduced cost to publish in an open access journal if you agree to review a certain number of papers per year.
So, I'm aware of a different Ponzi scheme. But also, Casey Snowhart says, "Hi, Casey. The poo blondes has been coming through in the CCs as blue blondes, poo blondes." Yeah. So the scheme I'm aware of is you buy membership to the journal, not like as to get the papers, but rather as a like you're part of the membership guild of it, and so then if you pay this amount of money, you get a discounted rate for if a paper gets accepted, like, or if there's a conference put on by the journal or something like that. I've never heard of something where the service gets rewarded financially in some way, whether it be through discount or something along those lines.
It may have been when some of these journals were newer. I don't know if they still do that. I don't want to say that I'm not sure. I'm really hoping that because one of my co-authors used to be a member of PeerJ, and I'm hoping that I can publish in there and it won't cost me $4,000 or whatever, but we'll see.
The only one I can tell you is that there is a journal called, I don't know if it'd be They might need a little smidge of genetics in it, but it's called G3, and there is like they have like waivers for good science, so they'll publish it for free. And there it's like you don't have to show mechanism or anything like that. Like it could be purely observational data, which is really nice. Like for the examples that I've seen, although there's a wide breadth, is like let's say you have sequencing data, and you're like I just have it, and I can't really do anything with it, but you want it out there. Like they'll be like, okay, we'll take it and we'll publish it.
Huh. Nice. That's cool.
Yeah, that's a neat way. And
that's open access too, or
yeah, that one's instant open access. Yeah, there's
nice.
There's some where nowadays you have to like pay for open access.
Yeah.
Otherwise, it like goes to open access like in X number of years. But there's some, like my paper in Science, I don't think it's still not open access, and it was published in like 2012.
It's been 12 years and it's still
like the way it's like Hi JD, welcome in. It is a crisis, Misadventures in Astro. And it's like how do you deal with some kind of like financial element to that, because it's like that pay to play system with like Nature being 10,000. Like if you don't have the funding, like y'all, if Danny makes an incredible dinosaur discovery, that there can be paleontology papers in Nature. It does not limited to like molecular stuff. Like
for sure.
Like you'd have to raise $10,000 after it's accepted to get in. Like and like what? Like how are you gonna? Like you've told us like how much 5,000 goes to pay for the entire summer. How are you going to justify in your budget $10,000?
Yeah, maybe they're assuming that like someone's academic department will foot the bill for that, or that people are independently wealthy or something. But I don't know.
It's
how much of that money is actually going toward paying the editors or anything from the journal, and how much is just going into the pockets of the execs? You know,
I have like that. Yeah, I know it's very variable depending on the journal and if they have something that's like for members or anything along those lines, but it's like, you have how much goes to the 6 levels of bureaucrats in there, and it's
exactly.
And I know it's not a popular opinion in the journal fields, but like if it's taxpayer money. Hi, Moonrise.
Should be available to the public for free. If the public's already paying for it, let's give it to the public for free. So here in California, the University of California system passed some sort of a stricture or something about that, where this is if there is somebody from the university system who is publishing, they need to publish in an open access journal. They can't publish in a paywall journal anymore, because like the UC system is taxpayer funded. It's funded by the taxpayers of the state of California. And so they also decided to unsubscribe from a bunch of these journals too, a bunch of the paywall journals. So like sometimes you can't access some of these papers in the University of California library system anymore. And like, fair enough, I understand that on some level. Sorry, I've got cat hair all over my feet now. But yeah.
I understand from like the moral perspective, and I'm like all about it, but the problem is there's so much science that you need to get a hold of, like for that literature search, to figure it out. There is this new law that was passed during, I think it was last year sometime, where all journals have to be public access. And
if they're going to get federal, like, isn't it like a federal law, I think, where it's like, if any of it comes through NSF funding or something like that, then it has to be open access?
I think it's NSF and NIH. It has to go through, and so one catch is that it's like now the for-profit ones are like, well, how are we going to pay for stuff? And the way they're doing it is they're just raising the publication fee, and introducing submission fees. It's like
the college application fees that you would have to
pay.
The
Common App
severely limited the number of colleges I was able to apply to. Yeah, I think I had 5 that I was able to afford. Yeah.
And that doesn't end at college. That's for graduate school, medical school.
Yeah.
Only postdoc applications did they not have like a surcharge for me to like have to like contribute money for. So it's that's the system, y'all. So when we're talking about these things of like the publication fees and everything else, like that's where all these elements are coming from.
Yeah.
Shall we continue on the?
Yeah, let's continue the video.
How could you possibly know? And also, why do I care? 2 perfectly good questions. But let me start with the actual news. According to a brand new study by Susanna Herculano Huzel, that's me. Theropod dinosaurs, that's the biped, fast-running dinosaurs like T-Rex, were the primates of their time with as many neurons in their telencephalon as you find in a modern monkey. T-Rex in particular had baboon-like numbers of neurons in its telencephalon. If you don't think that's very impressive, think of scheming monkeys that can swarm on you and trick you and steal food from your hands. But now,
I know we're pausing at like 30-second intervals, but like
that's what this is all about. Yeah, it's just like on my channel. Yeah.
It's the implication of that, right? Of those just few sentences are huge because it suggests level of quote-unquote intelligence, social dynamic and structure, the cultural element of information transfer.
Yeah.
Also, it kind of raises a weird eyebrow to me of like total brain mass in the animal if it's the same number of neurons, like just like spatial spacing of neuron, like structural features of the brain too, right? And like cranial space for the like there's a lot within those few sentences.
There's a lot of assumptions that are kind of sneaking in right there. It's not nearly as simple as I think the author would like it to be.
And maybe that's just us because of our training, like kind of dissecting away some of the implications of it. But it does kind of feel like there's a lot embedded in that statement of what having a certain neuronal number implies on a very broad scale. And it all that's what it feels already like a little bit like, aha, that's a weird thing to already point out.
I'll make this creature of monkey-like smarts get bigger than an elephant, with big claws in its feet and gigantic teeth that could pierce right through you. That is very much the stuff of nightmares for me. So how can I say that when there are no dinosaur brains around, preserved in a freezer somewhere that I could turn into soup, which is how I figure out how many neurons different brains are made of?
That is what the methodology is that we talked about, right? Like turning it into that single cell suspension and putting it into that machine and confirming it. So like that's absolutely on point. I kind of like how that part's phrased.
I do feel like the way that you said it is more interesting though. Like if it was kind of like walking us through the process, if there was an animation here or like something like that that's explaining the process, I feel like that would be A, more entertaining, and B, more informative. I don't know. Yeah, this feels more like tell, don't show, and I prefer it the other way around.
I mean, I'm a sucker for seeing methods too on videos like this. Yeah. And even if it's just, like, Danny, I get that it's like maybe a little silly of like show me the machine as it's counting and their peaks being forming.
That's cool though,
right?
You know, it captures people's attention and it gives them context and I don't know. It's much better than somebody just speaking into a camera. I say as I'm speaking into a camera here, but. I don't know. That's one of the reasons I'm so excited to be able to do live streams from the field again, to just show people what it's like to dig up dinosaurs rather than just sitting in front of a camera and telling you.
Yeah, but that's not. Yeah. Let's be clear. That's not all you do. Okay, like you're not just saying. You have models behind you. You do the modeling. You do the 3D printing. Yeah, you dissect the videos. You look at the paper.
No, show and not just tell.
It's not. No. It's not just best. You do it successfully, sir. I will not sit here and have you equate the. No, it is a hard thing to do, and you do it amazing. So we're gonna leave that.
I appreciate that.
Like, if anyone's talking down about myself, it's me. It's not. I'm not letting you do it. But truly, like, back to the point, right? Of like seeing here the method is that she described. It's essentially what you're doing. We did it with insects, and it's the same with so Lita would sometimes get cell culture from mammals to work with when we were postdocing. It would be from a graduate student, and they were living neurons. But she did the exact same thing basically.
You're extracting neurons from a grad student?
Oh, no.
Hold still.
But like, you'd have the brain tissue from the mouse, like the hippocampus or whatever center you wanted to dissect, and then basically there's some mechanical damage that happens to separate out the cells and some detergents, and you wash away the debris, and then you're left with the cells. And so that's gonna be the exact same thing going on, right, with these specimens too. And it's like, yeah, it could easily be a really cool visual to see. And it's, I mean, I get for, we want to shorten down the video or what have you, but I think it's a neat element that you can talk over and see some of those processes. And then the caveat too of that alone is not sufficient to separate a neuron from a glial cell or any subtypes of neurons, because I think one thing that I would have liked to have seen in the present study as well, and we have the data for, at least in mammals, and I would assume in birds, is brain regions, and how relative proportion size of a brain region can correspond to maybe memory or task doing. Like,
that is a huge part of the rebuttal paper, as I'm sure you know. So yeah, we'll be talking about that for sure.
Yeah, like in ant brains, grab the model here, there's a structure called the mushroom body, and it's this, like, these little Cheerio like structures here. And this structure is in fruit flies, it's in mosquitoes, it's in bees, it's in termites, it's in all these critters. And so one hypothesis is they seem a lot bigger in animals that live in a colony. And so maybe complexity and proportionate size of these structures correspond to social complexity in the insects. Now, it's the only way to prove that, right, would be to artificially increase and decrease its size and see how social setting changes, and that hasn't been proven. But there are a lot of papers on just that structure and how it compares to almost intelligence in a way, right? And so it's like a neat little, it's not a new phenomena, this thought process. And so I was a little disappointed here that it's just this global brain setting versus, subsetting of those brains too.
Yep. That is going to be a huge part of the rebuttal that we'll get to. So, yeah that's super, super key idea there.
Shut up, Wesley.
Because dinosaurs actually still exist. That's right. Technically, modern birds are still dinosaurs. They're descendants of the ones that outlived that asteroid that hit the Earth 65 million years ago and killed all large creatures on land, making way for the small mammals and some land-dwelling bird-like creatures that already...
And I like it's the small mammals too. Like, we talked a lot about the residuals of aging from there, and like that's a nice little extra there, yeah.
It is nice that she says small mammals, because they really were tiny during the Mesozoic. The very biggest mammals that existed during the whole age of dinosaurs were maybe the size of, like, a big loaf of bread. They weren't huge animals. Maybe a badger, but yeah.
It's always weird to me to think about that size. Like, it's not...
Yeah.
And in part, it's because as a kid in the media, you see the Flintstones, and they're with their dinosaur, right? Even if yes, they didn't live at the same time, but the size comparison of there's a mammal and there's a dino and there's I don't know, that there's almost a mental disconnect of yes, I know people didn't live at the same time, but why would I necessarily think of that size difference and how it influenced our lifespan in today? There's a lot of implication to it that I think goes unsaid.
There's that, and there's also, people forget how long the age of dinosaurs was. So mammals and dinosaurs evolved around the same time, or at least mammaliaforms before we get our true mammals in the early Jurassic. We had, mammaliaforms, what we would recognize as mammals back in the Triassic. Same time as the dinosaurs, or even slightly before. But for 160 million years, basically, mammals were small. Mostly lived underground, kind of in the shadow of the dinosaurs. Maybe mostly came out at night. And only in the last 66 million years, have mammals been able to diversify into, squirrels and bats and horses and camels, rhinos and whales and manatees and etc. Like, for the entire Mesozoic, for 160 million years, they were just little guys. That's the majority of the history of mammals. We were kind of under the boot of the dinosaurs. And, that explains so much about mammal biology today, is that legacy of kind of being, subjugated under the reign of the dinosaurs.
Yeah. Fishman had a question, is how can we tell the fossils are reptilian versus if they're not mammalian?
Oh, well, by their anatomy. So, like, mammals have got very, very different teeth than reptiles. They've got different jaw structure. Their inner ear is very different. And mammals and reptiles have been separate since there were animals laying eggs on land. Like, dry land animals, non-amphibian vertebrate animals, right as they emerge, you have mammals and reptiles split. So they've basically been separate for, like, over 300 million years, if that makes sense.
Yeah.
Yeah.
It's one thing I've really learned to value on our crossover is the importance of the comparative anatomy that you do, and modern day animals to past animals, form being function. And it's like, I guess when it's one of those things that doesn't always come across of if you thinking like, when you work on a dinosaur, it's almost like an insular like thing. But really, the amount of knowledge, I mean, it's clear that you're a brilliant man, but like the amount of knowledge that you need to make these observations you have to be. Like, it's huge.
Yeah, because we have so little information for most dinosaurs. So, like, you have to be able to look at other members of the group and then figure out where these different traits evolve, and then who has what, and how they're related to each other because of that. And, like, paleontology is all about context. It's not an insular thing. You've got to understand a lot about a lot of different things in order to actually be a good paleontologist. It's not specific or insular in any way.
And it's just
a broad base of knowledge.
And it's amazing. That's why when you play Metazua too, it's just like how on earth did he know this, like, random phylum that doesn't make any sense, like, not even in the immediate vicinity, but you have to, like you were saying, because to make these comparisons, like as Fishman asked, of like mammals versus reptiles versus birds versus existing dinos versus, like, we find a femur in this dinosaur, what does that mean for its gait behavior? And it's like, that's an insane amount of things to speculate. But no, it's like, if you have the comparative anatomy and bone structure of modern animals and you look at the function and form of this one, you can make that implication there. And it's such a powerful tool, and it shows, like, again, like, just, I don't know, Danny, how brilliant you have to be to do what you do, and it's very cool.
I don't know. I think a large part of it is just thinking in analogies, and that's kind of how my brain works. Is I really like analogies, just how I function, and that is the kind of thinking that can take you pretty far in paleontology.
Nice. I mean, I love it. It's just such a cool thing to be able to see. It's a really, really powerful thing.
It's a lot of fun. Yeah, I love my field. Yeah.
So, if you can figure out how many neurons go into a bird brain of a certain size, and you can figure out what size was the brain of different bird-like dinosaurs, then you can do the math and estimate how many neurons a dinosaur brain had. But first...
No, you kind of can't. That's the thing. Oh boy, we'll be getting this in the rebuttal paper, but birds are not necessarily a good analog for dinosaurs here. Like, you can't use them as a good proxy for, like, a bird of this size. A bird that weighs 1 pound has, 1,000 neurons. So a dinosaur that weighs 10,000 pounds has a billion neurons. Right? Like, that's not how it works at all. like somebody who just mostly studies brains and kind of thinks of the world in terms of brains, like, oh, brains have to be the key to everything. No, there's a lot of other things that you have to consider when you're talking about dinosaurs.
So one thing that comes to my head right away is that difference. And this, I know it's insects are very different, Danny, but I'm just like pulling on what I know, right? And if we look at two casts of ants, the nurse caste and the soldier caste, and the very first time there was sequencing done on their brains, they took the entirety of the head. They just chopped the head off and put it in the sequencer, basically. I know there's a lot of processing steps, but the point is all the tissue went right in. And so what was actually thought and identified was the nurses were called brainy because it was primarily brain tissue that you got out, and the soldiers were called brawny because it was primarily muscle tissue that you got out. And so it was like, well, the soldiers are stupid and the nurses are smart. But what turned out was, if you actually did the dissections, while the soldier has a lot more space in its head, it did have a lot of muscle to move its mandibles. If you dissected out the brain and did just sequencing just on the brain tissue, you would find vastly different answers when comparing the two creatures. And so, and even cell number, which was, you would predict, like, here, let me find a picture just to kind of illustrate why this is, I think, a neat finding. Hypnotus. Okay, images. Okay.
To answer Samar Faye's question, yes, we'll get to that, Samar Faye. Absolutely. Birds have very different shaped brains than most dinosaurs.
Or maybe even this one here, this image, we'll make it bigger. So that's a soldier, the big one, and the nurse is the small one, the minor. The total number of cells, so the nurse has roughly 90,000 neurons.
Okay.
90 to 100, depending on, there's some variance there, and experimental hands and everything. The major has 100 to 110,000. So not a huge difference in terms of the numbers. And and why that's, I think, interesting is because, like, if you're just looking at cranial structure and if you knew what is like the ratio of brain in the nurse, and that's the ratio that you were trying to put onto this animal, you'd have a wildly different number. And if it is brain size and neuronal number that informs the quote intelligence, this soldier should be miles smarter than the nurse, given that kind of mathematics.
Yeah.
And so I think it's an additional layer of complexity that isn't necessarily accounted for in this model.
That makes a lot of sense. Yeah. And I would agree with you that it's, those, like, neat and tidy ratios there, like, this scale is the same exact way, it's going to lead you into trouble. Yeah.
And it's hard, right? Because you're trying to build a model, and a model is going to be faulty. But, like, and so obviously, like, I think it's always
perfect.
Yeah, and it's like in the paper you'll put caveats to this model, and here's things that I would change, or we can't account for these. But it feels like here it's almost so much where it's like, well, then what is really the point of this model? Like, there's just so many caveats to it. Like, it's not really informing us anything anymore.
Yeah, it's causing more confusion than it is causing elucidation.
Yeah. And again, that might just, I'm not trying to be cynical about it. I'm just saying, like, if it's causing so much, like, even if you're writing it, you're like, man, there's so much here that isn't answering my question. At a certain point, you're just like, I need to reevaluate the model, because then what's the point of publishing on this if it's so almost broken in a way?
Yeah. It would have been neater as, like, a conceptual paper where it's like, here's ways that we could figure this out or figure that out. Like, if she had some co-authors on it, and, like, but trying to draw big, impressive conclusions from like such flawed data it's not great.
I get, that's a good way of phrasing it. Like, I would take it as, if you just took away the conclusions here, if you were just trying to demonstrate what we could learn in doing something like this, right? Like, make it very theoretical. Like,
It's
sure,
like a thought experiment kind of thing, almost.
yeah, like, sure, apply it to dinosaurs, because, like, how else are you gonna to get this, right? Like, sure, totally great,
Yeah.
but like,
Technology.
exactly, Sleazy,
What
technology,
is that all about? Is it good or is it whack?
exactly, Sleazy. I think that would have been less controversy behind it, right? And the follow-up paper wouldn't be a rebuttal, but it would be a build. You'd be citing it. You'd be using it as a framework of, like, here is this thought experiment we laid out. Here are things that, you know, like the author said, maybe could be changed. Here's how we, the experts in these particular subfields, came together to answer those particular points.
Right. Yeah. If only. Yeah.
Have to have good reason to believe that the same proportionality that applies to birds already applied to dinosaurs like T-Rex, which is what I just did. In a paper published in early January of 23 in the Journal of Comparative Neurology, I show that dinosaurs cannot be treated like a mixed bag of creatures like they used to be treated. Theropods and ornithischians and sauropod morphs thrown in the same bag as if they were all the same thing, which was how
Nobody's done that.
scientists had previously...
That's really frustrating too, is that, like, we've got... You had different encephalization quotients for these different groups of dinosaurs. It's not like, oh, dinosaurs all have the same level of intelligence or braininess, or whatever you want to say. I don't think anybody really... That's not like that was the assumption before this. You know, it's almost like a... Yeah, almost like a straw man there.
It feels like it was an assumption a while ago.
Maybe back in, like, the 50s, sure. But not really since, like, the discovery of Deinonychus in the 1960s.
Okay.
Yeah. Like, I don't know if I really remember this from the paper, but just from that line in the video, it kind of makes me suspect that her view of dinosaurs is a little outdated. Yeah.
And I guess Astronomy Show even brings in the point of, if it's Jurassic Park, like, I know it's inaccurate, Danny, but let's say that was the dino information. That still suggests that there's this, like, the intellectual contribution of of the raptor versus the T-Rex versus the Dilophosaurus is clearly different. But it's like, right, because they're clustered together with group behavior versus with the raptors versus individualistic of the Dilophosaurus, and, you know, it could be it's wrong, but, like,
sure, but even in there, like, in a pop culture depiction, you've got, like, you know, different dinosaurs with different varying levels of behavioral complexity, we'll say.
Yeah.
In a super popular film from 1993, you know, from more than 20 years ago, 30 years ago at this point, shoot.
So, do you think it's just an outdated literature search, or just there was no literature search, it was just an assumption that was kind of built into the paper?
Yeah, I kind of feel like it's the latter.
Mm-hmm.
Yeah.
Again, that's too bad, because I feel like there could be so much coming out of this. In terms of, like...
It's a neat idea, but, like, this is not a single person project. It should not be. There should be multiple people with multiple areas of expertise contributing to something like this.
Mm-hmm.
It's not a single authorship kind of project.
That could have almost corrected some of the elements that we're
Definitely,
saying. You know,
it would have, I think. Just having perspectives of different researchers on this, some of whom maybe they know a thing or two about dinosaurs. That would have helped a lot. Yeah.
We thought that dinosaurs were mesotherms, meaning neither cold-blooded like modern lizards, ectotherms.
This is not... I don't know where she's getting this idea either. Like, we've got so many different lines of evidence that the majority of dinosaurs were endothermic. That seems to be the basal state for dinosaurs. They evolved from warm-blooded ancestors. So they're like, oh, dinosaurs were all mesothermic. Nobody says that. I don't know where she's getting this.
So I guess you're using a faulty base to try to explain some of these things with that, right? Because like there are papers, right, that suggest like of metabolism, like we talked about, and correlating that to this warm and cold bloodedness. So there is data behind this, right? But not in this presentation, like not this element to it.
It feels like she's saying, well, everyone assumes that dinosaurs were mesothermic. You know, it's like, no, what are you talking? Nobody assumes that. That's not what you would get by actually looking through the literature about this either. I don't know. Maybe that's something you'd get out of like a popular book. A book written for a popular audience.
Mm-hmm.
But it's not. If you're familiar with the literature and the current thinking on dinosaur metabolism, you're not going to come to this conclusion. This is not going to be your assumption. And
I forget this. Is this a figure that was in the paper?
I think it is. Yeah.
Yeah. Because Sloppy was like, well, what about the citation for this? And I was like, wait a minute, I'm pretty sure this was actually in the paper, like this particular figure. So yeah, Sloppy. Presumably there was some flavor of citation to go along with this, but like as Danny said, we don't like at what date of it there could have been. So like while this is an oral presentation, it's coming from the paper, which should have citations. But yeah, I'm pretty sure I saw the second figure there, with like the body RAS as like an argument, as like a sub-figure for this.
So what's weird is that sorry, go ahead.
Oh, just welcoming in Nerduino, NASA
Nerduino,
scientist extraordinaire.
Good to see you. Welcome. Yeah. Maybe I'm jumping the gun here, but man, we're taking a long time to get through this video. I'm sorry.
No, I think it's just like because we both have these unique perspectives, and we're just. Again, I think it's because we're jazzed about the idea of it, right? And like we want the finding to be good.
Yeah.
If we were just like, man, I think we'd just probably sit and watch the video.
Exactly, fall asleep. Yeah, but I don't know. One of the conclusions that she comes to in the paper is that like sauropod dinosaurs would have been ectothermic, cold-blooded, because they had not very many neurons in her estimation. And that is completely runs counter to basically all the other evidence that we have for metabolism in sauropod dinosaurs. There was an interesting case too where she's looking at pterosaurs and trying to estimate their metabolism based on their estimated number of neurons. And she had two different species of Rhamphorhynchus in there, which is a toothy pterosaur from the Jurassic. It turns out they're actually the same critter. Like, they've been synonymized. They're probably the same animal. But for one purported species, she says it was cold-blooded, and the other one she says it was warm-blooded, based on their different neuron counts. It's like, it's the same animal. You're looking at two different individuals of the same animal, and you're coming up with wildly different results, which lead you to estimate that they had different metabolisms, when it's like, they're the same critter. Yeah.
Oy.
So this is pointed out, kind of pointedly, I guess, in the rebuttal paper. And,
I think it's one of those things, too, where, it's really hard to do this in something that's extinct. Like, I think we all fully recognize it. But if you were using in today's animals this methodology in a living animal of taking metabolism as a function of neuronal number.
Yep. It doesn't work.
Right. And it's like if you and here you can test it. Like you can actually do the measurement, right? And so I think it would be one of those where you would want to do that, and you can do that on an animal that exists today. You would probably want to do a testing at that level, and then maybe you could go back in time to do it.
Yeah. They bring this up in the rebuttal paper too.
I think it'll be nice, like, as we're going through this, that a lot of the points that we are bringing up are what the rebuttal paper also brings up. And so it's like we're almost writing our own rebuttal paper currently as we're chatting about this.
Yeah, it should be hopefully pretty quick going through the rebuttal paper, because we're mentioning a lot of these points right here as we go through the video.
Which I guess
hopefully this is more entertaining than like just going through the paper afterward.
Yeah, and I think it's kind of neat that we are like, I mean, I know we both read the rebuttal paper, but I think in this conversation, I know we're not going in order of the rebuttal paper, and so it's like we're just kind of coming up with what we think are holes with our expertise and how we might think about plugging them, which I think is really cool. All right.
Nor warm-blooded like birds, endotherms. But dinosaurs separate so neatly if only you're willing to accept that not all dinosaurs are the same, just like not all mammals are the same and not all birds are the same. Why should?
And so, like you were saying, that's an existing knowledge gap, right? Where it's like, or it's not knowledge gap, it's like we already know that. Like that's
yeah, that's nothing surprising.
Yeah.
Yeah.
Okay, so if you compare the brain and body size of different dinosaur species, like I did, you find out that some, like a gigantic quadruped dinosaur, had just the brain size that you would expect for a cold-blooded modern lizard, and others, like all the bipeds.
And so by saying, oh well, they have an encephalization quotient similar to a lizard, like similar size brain or similar size estimated neuron count to a lizard, well, it must have a metabolism like a lizard.
Mm-hmm.
It does not follow. That's not how these things work. We can actually look at the metabolism of sauropod dinosaurs by doing things like, looking at the structure of the bone, looking at the histology, how quickly they're growing. We've got a lot of really neat proxies for metabolism there, and nothing is lining up with what she's saying about that. They are not cold-blooded animals. They were, they had elevated metabolisms. They grew really quickly, and they need a ton of food to power their bodies. And there's multiple lines of evidence there. It's not just neuron count. It's just, I don't know, this reminds me of one of those old kind of trite sayings like, oh, well, if all you have is a hammer, then every problem looks like a nail.
Yeah.
If all you're looking at is neuron count, then you think everything can be solved through neuron count, and it's.
But okay, I can humor the idea. I don't agree with the idea that everything can be solved by neuron count, because I think a lot of these are just multidisciplinary. But if I humor that idea, I would still end up at the conclusion that the composition and arrangement of neurons in one creature, like let's say the reptile, doesn't necessarily inform the neural density and structure and organization of a sauropod. And that actually goes with the argument you just made a few moments ago about how not every dinosaur is the same, not every bird is the same. Like, there are these unique features of them. And so I think having that one-to-one comparison is inherently flawed, even if you buy the argument that neurons inform metabolism.
Yep. Yeah.
It does mean that if that is the theory that we go with, it means that you cannot use neuronal counts to inform the metabolism. Like that you need.
They might be indicative within certain clades, but looking at it across different clades, it just kind of falls apart. You have too many variables there.
Mm-hmm.
Maybe you'd have neat correlations in birds or in mammals, or even within particular groups of birds or mammals. But when you're comparing lizards to sauropods, or something like that, it's too many other variables that are making things more complicated.
I think another thing is that how you told us 40 species have been found to have these the brain cavity intact, right? Of those 40, how many replicates are there? Right.
Yeah, not very many.
Right, and so then
and the ones that we do have replicates of, where you've got multiple individuals of the same animal, you get differences there. It's the brains don't match up. There's a surprising amount of variation there.
Right, and so the variation, taking that into account, what if you got on the sauropods, for the sake of argument, there was one measurement that you had, and it happened to be a malnourished one, and so it was really small.
Sure. Yeah.
And so, the density that you get, or the neuronal numbers, it's just because of the individual variance that you have, and that's not going to account for those differences. And so, that's what makes me go, oh, wait a minute, there could be a lot of, cool things there if you just had the aggregate number, but, we don't.
And it's not even just that. We'll get into it with the rebuttal paper, but estimating the brain sizes of these different dinosaurs, it seemed like in her paper she was kind of assuming that, like, oh yeah, the full mass of the volume of the brain case corresponds to the volume of the brain.
Yeah.
That's not the case. Like, critters like crocodiles, their brains don't squish up against the inside of the brain case. There's a lot of, like, filler material in there around the brain. So the size of the brain case is not the size of the brain, and that seems to be the case with most of these dinosaurs too. And so it can be difficult to actually estimate the size of their brains, even if you do have a proper endocast, with the brain cavity. So, yeah.
And that was the same in the ants too, that we just talked about, right? Like in the nurses, yeah, it goes up to the edges with a little bit of filler, but then there's a ton of filler on the soldiers, and so if you were just naively looking at the head space, it would be totally off. Yeah.
Yeah, so that's one of the reasons why birds aren't always the best proxy for dinosaurs, is because birds are evolved for flight. Like, they've got to be as efficient as possible in terms of space and weight and everything else. They don't have room for, they don't have that wiggle room where they can have a bunch of space around their brain. Everything's got to be packed in so tightly, It's like the difference between, your couch at home and then an airliner seat. The airliner seat's a lot smaller, but again, it's also much more lightweight and not as comfortable and everything else because it's got to fly.
Yeah.
Yeah.
I like that analogy a lot. That's a really nice analogy.
I just came up with that right now. See, I like analogies. That's
yeah. No, I mean, it's a great way to explain concepts, right? If you can make it relatable. There's been a lot of good zingers coming out today. Like, I really like that. It's a great way of thinking about it too. Like, yeah. It's like the economy seating versus first class for your brain.
Sure, yeah.
T-Rex-like theropods had just the brain size that you would expect for the species of birds that can be traced back to pre-asteroid times, which makes it very reasonable to expect that the same scaling rules that apply to the brain.
So that's an interesting one of scaling back in time.
Uh-huh.
If I'm understanding it correctly, it's like, birds evolved at a certain time and they've kept evolving because they survived, and we're trying to scale back to the same time as if it would have been in the dinosaur. From what we've talked about, there was a mass extinction event, right, of birds.
Oh yeah, almost all the birds went extinct alongside the dinosaurs. Only a few lineages survived.
So we almost had like we had a lineage bottleneck happen. So
an extreme bottleneck, yeah.
So would that be
like 95% of birds or more died out?
Yeah.
Bird species.
So,
almost all of them.
So would that then be a fair characterization to try to trace back?
It might not be, because, it could be that the birds that ended up surviving, maybe it was in part due to something to do with their larger brains, or I don't know. It's like, because you have that bottleneck there, it complicates things even further.
Right. It's like you don't know if there was some effect of brain. I know that's a very crude way of putting it on survival.
Yeah.
Like, if it were ones that could better adapt because they had the ability to remember better, or if it was ones that didn't have as many neurons, that didn't use as much energy, and therefore they could scrounge for, there's less food needed, and that's the one that survived better. Like, there could be multiple situations at play here, and it makes it super complicated.
Of these modern birds, like ostriches and emus and chickens, also applied to the brains of T-Rex and its cousins, which means that you can do the math, like I did, and calculate how many neurons these dinosaurs had, which was as many as primates today have. Why is that important?
You had an eyebrow raised, Danny.
I don't know. I also... Maybe this is fair and maybe it isn't, but, I don't get the impression that she wrote the script for this, just based on, how she's kind of reading it.
Mm-hmm.
And it just comes across as kind of, forced. And somebody who does science outreach full-time, like you do, Boleyn, it's... I don't know. It could be a generational thing too, where it's just people my age are authenticity is one of the most important things to us.
Together, we can rule the galaxy.
I don't know. It's just if something feels contrived, it's like I don't like it. And this feels a little contrived. Like having a professional film crew there and having this professionally edited and like maybe somebody else was writing the script for her. Like this is their whole production team involved with it. It squeaks me out a little bit. I don't know. Yeah.
And Penn Center, welcome in. Thank you for the resub, Penn Center, for 5 months. Good evening, Penn Center. Welcome, welcome. And F Waddle, thank you for the follow. Welcome, welcome. I guess my counterpoint to that about the video crew and the imagery. So it does. I get actually a little bit of the opposite sense. This flow to me flows like the paper. I get very much vibes that this is the same style of presentation that she was doing in the paper, and I guess
I didn't actually read the paper before today's stream. I haven't read it since it came out, so
I did and I haven't seen the video until today.
Oh, okay.
So a little bit of that, like that
it's
UI.
good having these different perspectives here. Keep each other honest. I appreciate that. Thank you.
But I get what you're saying. The flow of the paper is one that was, I mean, as a function has to be. It's very recited. It's very much like a forced story being told, right? And so I wonder if that's a little bit of what's happening here too in the story of the video crew. Now, I will say it's very cool to have something like this.
Yeah. Shoot, I wish more of us had these kinds of resources to be able to like have professionally produced videos to go with the press packets for our papers. Holy cow, would that be neat?
Absolutely. And the reason why I really like it is because there are a lot of, I mean, as Sloppy Salamander almost pointed out at the beginning, there's the armchair paleontologists, right, that don't have your expertise, don't have the field research, don't have the training, don't have like the knowledge base, and they can have a video where they're just kind of kicking back at their desk and be like, dinos are stupid or whatever. And it's like there's something to be said for trust of something that looks professional. And that's even in like a stream, right? Like your office, my friend, is amazing. It is so cool to see the images, the photos you've got hanging, the 3D prints, even the texture of the wall looks like it belongs. Like it is super, super well done.
I took a lot of care to try and make it something that like appeals to me in terms of aesthetics. Like I love this. I love working here. But also, I wanted that to kind of reflect my background and what I'm interested in, and like, I don't know. I didn't want it to feel slipshod or slapdash.
And it doesn't. It feels incredible. But I also think it's a reflection of you. Like it's that fun. There's that fun element to it, right? And the imagination of it, and the asking questions. And this, while it comes across as that very professional side of things, it almost comes across as a little dry, where it's like, like it is maybe placed things, and maybe it is set up in a way to look professional while not representing her. And maybe I'm reading too much into it, but I think
we don't know her personally,
for sure. It would be nice. Like I like the idea of having a professional crew produce something like this because it is so unique, and it is like if we had more data like this, more science done where we could be the people in charge and like have these cool videos, maybe we could bring that into people would be more likely to trust us, right? As scientists.
And that also, again, one of the reasons why I'm hesitant to like critique a video like this, why I'm a little bit hesitant, is because you and I both know that a lot of our colleagues in science are deeply suspicious of anything that's, speaking to the public, telling a story about science, any of that stuff. Like, everything has to be super dry and clinical, and, if you're going through the effort to produce a video like this, it's like, well, that's suspicious. What are you trying to sell here, And I don't want to be like that when we're talking about this. Not at all. It's really cool that there is this video and that it's communicating her ideas pretty clearly. I just wish she had some co-authors on the paper who, you know, work on dinosaurs. That's really the prime thing. Yeah.
I think that's the thing too, right? Is if there were maybe it cut to if it was the same video, but it was a rebuttal paper. It was produced the exact same way, but you had different perspectives.
Yeah.
You know, and even if, you know, saying very similar things, but like maybe different elements of it. Number one, you'd see the personality of the scientists come through, which I think would be a helpful element. Like, I think that's one thing the video doesn't do well. It doesn't really humanize her. It is like very dry and methodical, and I get why it's done like that for professionals' sake, but I think it also makes a scientist unapproachable. And I think that's almost one of the reasons why you and I do this, is to make sure that we are approachable. You can ask us questions, and you should not be worried to ask questions, because that does a world of damage. Like, I know there's a lot of people who like are nervous. Like, even to ask you and I, like sometimes they'll write, someone will ask Claire to, you know, in your chat as a mod, they'll DM Claire and be like, I'm really nervous, or Lolanina, or Brit, or any of the other amazing mods, like, I'm nervous about this question, could you ask it anonymously? And you are extremely accessible, my friend. Like, you never give off the vibe that you're going to say anything judgmental or put down anyone, but there's like the inherent fear, right? And so it's like,
yeah,
that's, I think, an element maybe missing from some of these videos too, is that like yes, she's clearly smart. I do not question this woman's intelligence. Like, she is clearly smart.
Yeah. She seems to be well respected among her colleagues in neurology as well.
For sure. Yeah.
She's a big name, I think.
Yeah.
Yeah.
And we question the science behind it, not at all what she is. It's just the science that's being put forth, and I feel like a little bit of humanization too would go a long way to that. You know?
I agree. Yeah.
Important because primates are these relatively small animals that carry a very large number of neurons in their brains, the largest amongst mammals. We're talking a couple billion neurons here. To have that many.
I thought cetaceans had more neurons than primates. Maybe she meant relative to size. Maybe I missed that part.
I didn't hear it, but I took it as, because a lot of the paper commentary seemed to be very specific on just the organisms that she was looking at, and almost like we're looking at a comparison to apes, and kind of ignoring the whales, which actually I think is kind of strange, right? Because again, in a naive world, I would have been like, elephants and whales are big, dinosaurs are big. I wonder how that scale, and I get that that's a very crude way, but just like from a very naive perspective on sizes that are presented to me in terms of, like, you know, those figures that we looked at with the guy, like the silhouette, and there's the dinosaur, and you look at like proportions. Yeah. I would never have thought ape to go for first versus an elephant. And elephants we know they have culture and intelligence and so a lot of the factors talked about could have also been done a little bit on that front, you know. But maybe I'm reading too much into it.
Neurons, either you're a huge mammal like an elephant, a whale, or at least a giraffe, or else you're a primate, or you're a crow or a parrot, even if your brain is not huge, or you're one of those earliest birds like these theropod dinosaurs with a primate-sized brain. In any case, this means that
I don't know. So Tyrannosaurus isn't really on the direct line to bird ancestry. Mm-hmm. It's not even a Maniraptor-formed dinosaur. It's, And so calling that an early bird... Birds are like a really specialized group. They're very, very specific. It's, I don't know, drawing such a close comparison between T-Rex and modern birds, I don't know. Again, with some co-authors who work on dinosaurs, she wouldn't have fallen into that trap, I feel.
There's that phylogeny that we looked at, I think last time or the time before, that's kind of looking at that trace and seeing where different, the T-Rex radiation was, and that's why I keep going back to the Troodontid, and like that lineage of how we trace that family tree. And yeah, my memory was, I'm like, I don't think T-Rex is close enough to that split to have made reliably that kind of, and I get we need,
and the structure of the brain is really different too in T-Rex than it is in modern birds. Like the forebrain is a lot smaller in Tyrannosaurus than, you know, it's just a different kind of animal with a different kind of brain, and it's going to have a different lifestyle and probably different behaviors as a result. It's probably going to be, frankly, more like crocodile-like. And I only say this because crocodiles are the only other group outside of birds that dinosaurs are closely related to.
Mm-hmm.
It's like there's a huge in-between that's missing there. So it's like, oh, do you do bird or do you do crocodile? It's kind of this unfair binary when we're comparing these animals, like a Tyrannosaurus to modern critters. But like if you have that binary there, and is it bird or is it crocodile that their brains are more similar to, the brains are more similar to crocodile brains in terms of their structure, in terms of their morphology. They probably had behavior more complex than crocodilians, which are, you know, usually sit and wait predators. They're not like walking around actively stalking prey and hiding in the bushes and this and that. Like it's probably a simpler lifestyle that crocodiles have to a critter like T-Rex, but the brain is more similar to a crocodilian, so than it is to a bird. So yeah.
And there was that current bio study as well that suggested that the number of cells in the forebrain of birds is similar to apes. But like you're saying, if the forebrain number in the Tyrannosaurid we know is different, I assume because of structure, then that's another line of evidence that this is might be an inappropriate comparison, as it were.
Yeah. Trying to use bird neuron count and just be like, scale that up to get a T-Rex's neuron count, you're going to run into some problems. You're not going to come out with the right answer there.
And because of the anatomy, like you're saying. And also, by the way, just as an aside, it's kind of cool that we can have that kind of estimation of, like, if you're looking in the forebrain area, how it might be influencing things, right? Like, how does the forebrain structure, cranial structure, correspond to the forebrain itself? That's a cool thing, and it doesn't seem like it's necessarily the most complicated metric to be able to pull out.
Sure. Yeah.
Before we continue on the video, Neil had, I think, an important question of the journal. What journal was the paper published in, and who was the audience? So the journal is Journal of Comparative Neurology, and I assume it's for neuroscientists. Would be so. It was like a peer-reviewed study, Neil. So it's not like for mass consumption. I mean, I guess, you know, it's all, any paper can be for mass consumption, but it seems like it's a very field-specific point that they were going for, rather than it being for other non-scientists. But was it for neurologists? I have actually, full disclosure, up until I read this paper, the neuroscience stuff that we publish, we've never looked at this paper or this journal. And that's more looking at neuroscience of, like, what do these neurons do in a behavior setting, like more of the nitty-gritty. This might be something that's a little bit more of a 1,000-foot kind of view, where, like, the human connectome, for example. So, like, in flies, we've done slicing of the brains, and you can look at all the neurons, and you can see where the neurons fit, and you can see how the neurons communicate. But you can't do that with a human brain yet, just because you're going from 100,000 cells to a few billion. Like, it just doesn't scale yet. And so instead of neurons, you have zones of, like, this zone responds to this behavior, this zone does this behavior, versus down to the neuronal level. And that connectomics has been more comparative neurology. And so maybe that's what you would publish here. I'm, again, totally spitballing, but that's, like, what I would take as something that would belong here.
And I, maybe kind of building on that a little bit, I think this author, I'm pretty sure she's published papers on, like, estimating brain size in hominids before, like, fossil hominids, like human ancestors and our relatives and stuff. I think that's kind of her area of expertise. So, like, trying to broaden that out to dinosaurs, thinking that's going to be real simple.
I guess that's hard, because it's like, you would want her on a paper doing this.
Yeah, for sure.
Right, like,
Yeah.
that expertise is really important, but like you said, the trace backwards is such a big jump.
Yep.
It's not, like,
Yeah.
it's not even with, it's like not even within birds.
Mm-hmm.
It's like, it's millions upon millions of years through lineages, and it's just, you need those intermediates that we almost don't have to be
Yep,
able to do that,
exactly.
yeah. Because, like, even with Neanderthals, as astronomy show mentioned, like, I think you and I talked about this. If you can feel that ridge on your skull, that means you've got a higher percentage of Neanderthal DNA than others.
Is that on the sides?
Yeah, there's that, like, indent, like that divot in your skull.
'Cause I've got that pretty pronounced right here and right here.
Yeah, so I do too, and so does Dad, but my mom doesn't have it at all, and that's a percentage of Neanderthal DNA that you have in your genome. Like, if you have more, it's more likely that you have that divot, right? So it's like, there you even have some kind of output for if you're estimating Neanderthal or other kinds of human lineage versus, we don't have these intermediates here and, like, that direct output.
Yep.
Yeah. It's still, again, it's fun, and I would want her on the paper, but I want, like you said, the experts too.
Yep. And so Marfay also makes a really good point, like, can she prove this works with kiwis and elephant birds, even, like, these critters that are closely related to one another? But the thing is, that wouldn't garner as many headlines, because you're not dealing with T-Rex, Like, there are other groups of critters that you could publish on and get better results for, but they're not as, attention-grabbing as Mesozoic dinosaurs. Especially T-Rex. Like, all of the press with this paper was T-Rex this, T-Rex that, T-Rex super genius, smart as a baboon, blah, blah, blah. Like, in focusing on that dinosaur, it seems like it's an attempt to kind of grab headlines.
Do you think that this paper could have been done if they did do the birds and then also did the dinosaurs?
I mean, dinosaurs seem like maybe step 8 or 9 or 10, and if you're gonna use birds as the proxy here, it's like do some extinct birds. Let's start off with that. Then maybe we can stretch it to Mesozoic dinosaurs eventually. But you got to prove that the method actually works first before you apply it to dinosaurs. Yeah.
Yeah. Okay. I that's what I was kind of going with too, of like the possibility of there being, this connection of like if you at least did the bird one, and then you did I in the ideal world, I agree with you, that would be like step 8. But it would be a little bit stronger of an argument if you can prove it with something today as well, and then you'd be like, all right, based on this data that works here, let's extrapolate and do on dinosaurs next. And again, it's still a jump, but it's like feels almost a little bit less of a jump, as it were.
Very large numbers of brain neurons are not a modern invention. If neurons are the building blocks of intelligence, then creatures with primate-like intelligence already existed in the pre-asteroid world, and they were called dinosaurs. So yeah, not dumb lizards, more like mean, smart, flexible thinking killing machines. And here's the kicker. Since I discovered a couple years ago that with more neurons in the cerebral cortex comes a longer life when you're a warm-blooded animal, I can also estimate that if a T-Rex had about as many telencephalic neurons as a baboon has today, then it probably had a similar life history as a baboon. It took about 5 years to reach sexual maturity, and it lived
No. Neuron count cannot tell you how long an animal takes to reach sexual maturity or how long it's going to live. It does not work that way. We actually have methods of testing that directly, and they don't agree with what she's saying here.
Like, even in modern living animals, right? It doesn't agree.
Yep.
Yeah.
This doesn't even work in modern living animals, as far as I know. But yeah, I don't know, to try and use this as like an estimate for determining the lifespan of a T-Rex or when it reached sexual maturity, like, we have ways of actually testing this in the fossil record, and it does not match up with what she's saying here. It's frustrating that, like, it almost makes me feel like she's not familiar with the literature there, and could have really, benefited from having a co-author on this who, yeah, she wouldn't fall into this trap. It's frustrating. Like, it almost feels like she's kind of dismissing the fossil evidence and being like, oh, you paleontologist with your old bones, forget that. Let's estimate neuron count and then use that to determine how long these animals lived. Just, I don't know. It rankles me a little bit, Sorry. Being very emotive about this.
No. Look, I love the emotiveness. I think it's just like, oh, I'm just trying to think about, like, the data that she had, right? Like that suggested about the neurons and that population of them. It just, like, I can see where you would make the connection of, like, here is what it is in baboons. Let's track it back to dinosaurs. But as soon as you get that data, like you said, if there already exists fossil evidence today, right, which we know we have, and actually you've told us estimated ages that we can get based off the fossil record, right, of the growth rings, and we can get the metabolism. Presumably, you could get. There are some that we found that have, like with the egg sites too, and maybe you can couple that with figuring out how to do, like, the age of the animal, right? So there's all these different elements that you can connect, and so the data exists today that we've already seen, right? The data exists, so you can validate this hypothesis with the existing data. You don't have to ignore it. And I think a good scientist, if they have this, model shown, it's almost your responsibility to go check that data. Like you're saying, I don't know why you wouldn't check the paleontological data that's already available.
It's kind of thing like oh, it's a big mystery how long dinosaurs lived and at what ages they reached certain growth milestones and stuff. So let's use assumption-filled statements about neuron counts to estimate this. Like, no, we have a pretty good idea of this. Why aren't you aware of it? Yeah.
I also I'm gonna echo Sam's statement here. I did not much enjoy the idea of them being painted as a killing machine.
Yeah.
And maybe I don't think I'm being sensitive on this, but from all that you've taught us, they seem very complex. They're like it's not a brain dead animal that is just like killing things like it's projected in the movies, but like there's parental care, there's presumably culture, there's learning that happens, there's living in an ecological niche, there's all like nuanced complexities that are in a lot of animals today that it's important.
But when you use the phrase like killing machine, it's going to garner more headlines. It's going to like capture people's attention and their imagination, and like it plays into this stereotype about dinosaurs that, like, you're totally correct, it's not really helpful or necessarily accurate, but
it also goes counter to what the argument is here. If the argument is intelligence, the equivalent of baboons, I don't know about you, I don't think of a baboon as going to rip me apart and kill me. I think of it as like the video that she played at the beginning, which is like this mischievous, clever creature that lives in groups, taking my sunglasses. Or actually, one of my friends, he was in an area where the baboons are naturally existing, and he left his window open, and they came in. South
Africa?
Yeah, like he was going for a visit. And this actually wasn't his first experience because he had a different monkey species do this to him in India. But they climbed through the window on the dining room table and was eating the fruit off his dining room table, and then they jumped out when he found. So it's almost like the argument that you're projecting. It gets a little reverted when you make them be simplistic and painting that image. And so I get Chad as like, it's clickbaity, it's attractive to say, but there is a lot of damage to the initial argument that you'd already be having, just as a function of using this kind of language. And so it's not even like getting into clickbait anymore. Now it's like it's almost countering what the goal is that you're trying to present.
Well, when you say that, like, oh, dinosaurs weren't just dumb, cold-blooded, brainless killing machines, they were extremely intelligent, devious killing machines. Like, it's, I don't know. Why? Yeah.
Yeah.
Frustrating.
Much as 40 years.
And just as an aside, you told us about this recently too, and on your streams, of course, that we that's a rod range that we have is like an end range of 40 years. But you've said based on that bone record, there's no reason to suspect that it wouldn't live any further.
Yeah, I mean we don't have very many dinosaurs that have been sectioned like this, and we actually know exactly how old they were when they died.
Mm-hmm.
I think the oldest dinosaur we have is like 46, 47, something like that, according to the histo. It might have been that big Carcharodontosaur from South America that was named a couple years ago. It might be Meraxes gigas. That might be the dinosaur that's the longest lived. But we've hardly sampled any of these animals yet, so we should expect to find big old sauropods that lived into their 50s or 60s, probably. Yeah, and I think the estimate that she came up with for Apatosaurus or another sauropod was like, oh yeah, they could live up to 50 to 20 years or something like that. Like, no, they were definitely living older than that. Yeah, it's just to use a method that's like highly experimental and then come up with results that run counter to the tried and true methods that we already have, or like we can demonstrate that they do work. I don't know, it's frustrating like this. It almost feels like it's kind of disregarding the work that paleontologists have put into this. You're like, oh no, neurons, that's where it's at. Let's do that instead.
And I guess Sam points out too of evidence if there's any evidence of dinos living past their end of fertility. And I think one thing that you were pointing out too with the fossil remains, that of those older animals, it doesn't necessarily look like they died of just natural causes. It looks like they were in a bog that they got sunken down. So it's it's not really representative of the end of life time, but just of when they happen to have lost their life due to some outside threat versus old age.
Yep. I don't think we have a single example of a dinosaur that we think died of old age. Dinosaurs seem to have mostly lived fast and died young, and had really, I don't know, from what we could tell from, I'm not going to say they all lived action-packed lives, but it doesn't seem like most of these critters were living comfortably into their autumn years, and then they just, passed away, warm in their beds, surrounded by loved ones. Yeah, dinosaurs mostly did not reach old age, didn't even reach skeletal maturity in a lot of cases. They grew really, really quickly, and then they continued growing throughout their lives. Some of them kind of taper off, but, yeah, it's not as though most of them are living very long compared to what their actual lifespan could be. It doesn't seem like a lot of them even have what we call an EFS. That's like the external fundamental signature. That's like when the growth lines get so close together that they basically merge. And it's like, okay, this animal is done growing. We don't find that very often in dinosaurs. Yeah, and it's an interesting question as to why that is, but yeah, most dinosaurs were not reaching full skeletal maturity and dying. They were dying before that.
Do you think it could be sample bias, where the samples that are living a little loosey-goosey with their lives, end up getting caught in places where they're just they're dying, and that is helping preserve the way they die, so it might be that
all the older dinosaurs are retiring to the mountains where they're not getting buried, and well, there could be something I'm making a goofy statement right there, but there could be something there that we're not thinking of that could be part of that pattern.
Well, also, if you go on the argument of intelligence, and if you've lived long enough, maybe you just know locations to avoid because your cohort has died, And so there isn't necessarily retirement in the mountain hills, but maybe it's like these are the locations that we don't go forage at because it's deadly, and so but it just so happens that those locations aren't great for preservation.
It could be. It could be something like that. Yeah. Yeah. Yeah, because it does seem like in certain environments we get like a high number of younger, smaller dinosaurs.
Mm-hmm.
And we do get, oftentimes when you find one small dinosaur, you'll find a bunch more in the same location. Like they're hanging out in groups of like rambunctious teenagers. They fall into they get stuck in some mud or, stuff like that. Like it happens. It's one of the best pieces of evidence that we have of dinosaurs being really social animals for the most part, is that, oftentimes if we find one young dinosaur, we'll find a bunch in the same spot. And that could just be that, like, there's a curve in terms of mortality, where, like, you're much more likely to die at an early age than you are to, like, reach an old age. So I guess it goes down. But, anyway, there's a name for that curve. I forget what it is. But, it again goes back to the idea that most dinosaurs are dying pretty early on in their lives. Not many of them seem to be reaching a ripe old age. It could be due to sampling bias, or it could just be like, something to do with their biology. Dinosaurs grow for most of their lives. They grow for a really long time throughout their lives. It's not like mammals or like modern birds where, like, you grow for a little bit and then you're 1 year old and then you're basically your adult size or whatever.
Or disease state too.
Yeah, that's interesting.
Kind of how Sam points out, like, before the glory of modern medicine, like the lifespans of humans. Like, I know we've getting longer and longer, but for a long time it wasn't that much longer into a ripe old age, and it's like the treatments, and maybe there were population breakouts, or maybe there was something with stagnant water. Who knows? There could have been like, and there's no way that I'm aware of yet that we can test for like I guess there's the lung infections we've seen in dinosaurs, right? Like upper respiratory
stuff in the cervical vertebrae of sauropods.
Yeah. But like, I'm sure, but like viral stuff, there might be like, difficulty seeing it, or how we look for things. Like, there could be those elements too that like lowered the lifespans, and that wouldn't take it. It's not the point. Is that y'all? It doesn't account for it. It's not neurons that are accounting for it. It's life history that we see in the evidence of the fossil record from the experts in the field who've done the collections. Like, you just call you, Danny, and be like, hey, like, Danny, what do you think about this? Like, well, looking into the data, this is what we would see. And it's not that neurons can't be informative, it's that they cannot explain away all these other factors.
Yeah, it's much more complicated than just neurons. Like, maybe there's some sort of a loose correlation with neuron count and lifespan, but, like, if anything, that it doesn't seem to be a causal relationship, and it doesn't seem to be a particularly tight correlation either.
Yeah, which makes sense. If you're if you're removed and you're just trying to be like, all right, I wonder how these things work, that's a very rational argument to make.
Yeah.
I told you I was so excited for this discussion today. I was so pumped up.
I was too. Yes.
40 years to use all those neurons. Modern birds with that many neurons, which are parrots and crows, can also solve problems and create their own tools and build their own culture, which means that T-Rex already had what it takes to do all that. I have a whole newfound respect for dinosaurs. So, did you need to know that T-Rex had baboon-like numbers of neurons and could live up to 40 years, which means it had what it takes to build tools and technology and a culture that it could pass on to its young? No. But isn't your life so much more interesting now that you have that extra bit of information to think about, especially next time you watch a movie with dinosaurs? Also, You can be thankful for that asteroid now, or life would be much different. Maybe presided over these days by T-Rexes that had figured out how to cook their food and afford as many neurons as we humans now have. Yeah, that's a movie I'd like to watch.
I feel that was a very much talking down to us vibe. Is kind of what I got from that, of like, hey little idiot, isn't your life better that I told you something?
Yeah.
And also I think there's a lot of logical leaps in the argument.
Agreed.
Because it's one of those hypotheses that if you tell me, like you've talked about the T-Rex vestigial arms too, so there's a lot of there's so much evolutionary elements that are going down here that are being disregarded, that I feel like it's not telling us the full story. And I wish that it was a much more representative of the full story, that it's being told, like a more holistic view of dinosaur research, versus having this mentality of like, aren't I great that I told you something, is actually damaging for science communication. And I feel like this part of the video undermines the entire rest of the arguments that we made about having a production crew and being able to communicate your science if you're presenting it as, again, I enlightened you, you pleb, is what the vibe of it very much felt like.
It's not great. I don't know. Part of me likes a little bit what she was saying there, because I do get that question a lot as a paleontologist sometimes, especially from older people. They're like, well, what good is it to really, to study dinosaurs or these extinct animals, to dig up old bones, and the point that she made is like, well, isn't that cool? Isn't your life improved a little bit from knowing this? But she didn't say it in a way that was kind of condescending.
I guess the way I took it is that when she said it was, did you need to know? I took it as, this is superfluous information that does not enrich your life.
Oh.
Right? And so for me, and anyone who wants to interpret scientific data, this is actually important. Right? Because in order to get, you need to, okay, my daughter already likes dinosaur toys. I'm just throwing it out there. She has a dinosaur plushie that she loves. Okay, Danny, is it because I sit her in front of you? Is it because kids love dinosaurs? I don't know. But I think that she would appreciate and enjoy the fact that she could know, even as a kid, what exactly the dinosaurs are coming from in terms of intelligence, in terms of neurons, right? And so it's not like I need to know for my life to survive and pay my bills, but I need to know to satisfy this intellectual curiosity that I have about the world around me. And that's, I think, the way it's phrased is fundamentally flawed here in the video, because you did want to know it. And it's also important for your understanding of the rest of the world. Friends here in the chat, like our friend Moo here, who's a maker and crafting wizard, reads papers for fun on developmental gene signaling. I know this because he asks questions on it, right? And so it'd be one of those things where, for him, I think you do need to know this. And it's not just this empty sack of knowledge that we're getting. And so that's one of the things I'm fundamentally disagreeing with on this video, is I think we do need to know this. And again, not for paying our bills or for living, but to satisfy that drive that we have as people of wanting to learn. And so that's where I was like, oh, I don't know, really, that rubbed me the wrong way, because I think it's just important to...
Back when I worked in sales, in my previous life, when I lived in Montana, and I worked at a Toyota dealership, we would call that overcoming an objection in the sale, where it's like, well, why do I need to learn this? Well, I'll tell you why you need to know this. That's kind of what she's doing there, and it feels unnecessary in a YouTube video, because you clicked on this because you're interested in it in the first place. It's that's completely unnecessary. But maybe the thinking was she would show this video to, I don't know, administrators at the university or something like that, or like people that do maybe need to be sold on this idea of like curiosity and scientific knowledge.
This might be a stylistic difference, but Sam points it out as well. If you need to convince someone why you should care, you open with that.
Yeah.
And you don't put it at the end. Because if I've already sat through and watched this, I clearly care. You know, so
exactly. Yeah, no, that's a really good point. And you would think that like a production staff, people who produce videos like this professionally, you'd think that they would know that, but yeah. That is frustrating. Shoot.
So this paper, chat, the original paper.
Yeah, let's get into the rebuttal here. So, I personally know some of the authors on this, and there are a bunch of dinosaur people who are. We're looking at the rebuttal one, right?
Yeah.
In the anatomical record. And shoot, here's my anatomical record notepad. This journal sponsored a conference that I was at back in June that I presented research at. June of last year.
Nice.
Anyway, they are one of the journals that we publish in as paleontologists. It's not like a huge journal, but they're trying to grow. And like I heard some of the people from that journal speak about it at this conference, and it's like, good for them. They're, it's a respectable journal.
I like Charlie's Dragon says you're declaring your conflicts of interest.
There you go. Yeah. Shoot, this journal, they gave me this notepad for free. So clearly I am not unbiased in my assessment of this paper. Yeah. But anyway, it's, to me, just the number of authors in this feels like a rebuke to the other paper, because it's like, here's a rebuttal, and here's 9 different authors. Not 9, shoot, that's 6, 10, 11 different authors. Rebutting a single author paper, it's like, this is the way you should be doing it. That's kind of the point of this paper, is being like, here's what we actually know about dinosaurs. Here's some better ways to frame that question. Here's why the methodology was flawed in the paper that we're rebutting. That kind of thing. And I thought this was written in a way that felt, it wasn't too scathing, and it felt almost conversational in tone in a few places, which I appreciated. It's like, it's not too dry. This is a paper that's going to be cited a lot, I think, in the future, because it is trying to actually drive the discipline forward. It's like, part of it is a review paper, and part of it is a rebuttal, and part of it is this is how you would take this field in the future. Like, here's how you actually frame these questions in a way that take the data into account, provide proper context, and also this is how you frame these questions in the future, I guess.
Yes. I found it a little bit. I found it a little strong at the beginning, in terms of it's not. It didn't feel like it was necessarily published as a rebuttal. It felt like it was meant to be more published as kind of the second part of what you said, where it's like, this is how you would go about doing this. Here's a test case of what doesn't work, and here's how you would fix. It seems like, in reading it, it seems very pure in how you would go about it, but the abstract almost starts off with a fist punch. To me, where it's like, in recent years there's been interest. Lately this person argued all these nonsensical things, almost, is how the beginning reads. Which I get, but at the same time I think it would have been because I usually don't see references cited in the abstract. It's much more of an abstract idea, right? There are claims happening lately in research about this possibility, and we're gonna test.
This is direct. It was a call out. It was a call out right there.
Yeah, and so that felt a little. I don't know, surprising to me, I guess, almost. You know, of like, oh.
Does that not happen a lot in the genetics literature, for instance?
There are,
more,
but it's like people who hate
circumspect?
It's people who hate each other. It's like when you read it, you're like, oh, it's because these two labs hate each other. And usually it's like, it's the same, like if they're working on the same question, but they have vastly different like interpretations of the data, then they'll pull out, be like, well, this guy's, you know, this jabroni said this, and this jabroni said that. And it's like, and then, but then you know also like there's an undertone of like these two labs have a history, and that's a little bit why we're having this vibe to it. And I don't obviously know about the background, but I wonder too if almost a little bit of how you're saying it, of like, what if there was this undertone of, hey, neuroscientists, like consider talking to experts, and not, it's not that we don't want to test our hypotheses with you, but maybe you should come with us and like recruit us for something, and we're happy to work together. I mean, like, I wonder if there's a little bit
that felt like one of the like I don't feel like they ever came out and said that in the paper, but I feel like that was heavily implied, like reading between the lines, like that's what they're saying over and over again.
Yeah. Lobster Duck. Lobster Duck, thank you for the resub for 5 months, and burgers to you indeed as well. Thank you, Lobster Duck. I hope you're getting a lot of burgers tonight, madame. Welcome on in. But yeah, I felt like the rest of the paper came across some subtlety. Yeah, I know, Socks. But then, like, the abstract, it felt very...
Interesting.
I mean, they had, like, the author and the year, like, tagged. Right? And I think that was a little bit of, like, whoa.
Which, in a rebuttal paper, it's like, I would expect to see that, I guess. And I don't feel like that's entirely... Maybe it's just that dinosaur paleontology is a much smaller field than genetics, so it's like, everybody knows the paper that you're rebutting. If you do a rebuttal paper, so you might as well just name them, you know? Because there's usually just like one paper or one group of authors.
Oh, 100%. I'm not saying like don't cite it and don't demonstrate, but it's just surprising to me it's in the abstract. Like in the abstract, to me should read like, like here is how this works. Here is how, like, the thing that is, like, a popular opinion, and here's how we're going to answer it. So, yes, you're calling it out, but you're not calling it out with a citation, versus then in the introduction, like, there, I think it's definitely important to cite, like, this is the gaining traction, here's the publication, here's how it's connected, and here's why, here's what we're going to suggest that this is inappropriate.
I guess it is kind of strange to see a citation like that in the abstract.
It just, and again, maybe I'm sensitive. It just feels almost a little aggressive, of like a call out in the abstract, because that's the first thing. Like for chat, you know, when we read one of these scientific publications, like, you can ask different people what they read first, but I always go for the abstract first, and then I go for the discussion to like really get like what's the point of what they're trying to get across to me. And this very much like when I did that method, I'm like, ooh, all right, it sounds like a little infighting here, or like I guess outfighting, because it's between the different fields. Like if you look at, actually, it's a very diverse group of people on this author list. Like I know you mentioned.
I feel like they were making a point of doing that too. I feel like it was like this felt very intentional to have such a wide variety of different experts there.
Yeah, so it was just like Cell Biology Institute, Game Management, Biological Sciences, Spanish for Paleontology, I assume, for number 3, and then also mammals, like a Natural History Museum, like that is a very like, and that's just the first 5. There's a bunch more like that are listed down here, but like. Those are the primary affiliations. I'm like, it's a very impressive list of expertise coming together. Where, you know, it's like, all right, it's a lot of... I didn't look anyone up individually, but I did look and see, like, what they were experts in to compare it to the other one.
Yeah, 2 of these people, both of the Toms on here, Thomas Carr and Thomas Holtz, are both Tyrannosaur experts. They publish extensively on Tyrannosaurs.
Okay.
Darren Naish kind of does, like, tetrapod zoology in general, but vertebrate paleontology. And then the rest of these authors I'm not super familiar with. But yeah, so you've got some good dinosaur people in there for sure. Yeah. Oh, and I gotta change out my earbud because it's dying on me. Hang on a second. But yeah.
Our excitement is carrying us away, Danny. The earbuds are leaving
I
us.
can't hear you.
Oh.
Okay, what do you repeat what you said?
Oh, no, Sam, you didn't get me. Our excitement is drowning away the earbuds.
No, it's just I've been streaming for a while. It's just like 7 hours. But yeah. Anywho, so I got the backup.
Nice.
Especially for Wednesday nights, yeah. Yeah. Anyway, it's a good group of authors here, and I almost feel like they wanted the author list to be really big, almost as a, this is how it's done kind of a gesture,
Yeah, and I do appreciate that. I think it brings, honestly, not just the more credibility to the paper, but also like a better, more holistic approach to the publication. Like, we're just learning a lot more out of it.
For sure. Yeah.
What was, I guess, your take on like the most important elements of this, like in terms of the rebuttal? Like, what to you brought convincing evidence that was like, or like
I think
the highlights of the figures, I guess, like most important things?
I think critiquing the methodology by just pointing out that it's a lot more complex than just like scale up a bird brain to the size of a T-Rex brain and then calculate the number of neurons, and then boom, baboon intelligence. It's not that simple.
Mm-hmm.
So like actually looking at the structure of these animals' brains is really important. As you can see in this figure right here that you're showing, just the shapes of the brains are very different from between like a T-Rex and even like a paleognathe bird, like that emu there.
And this kind of data, Danny, how is this based on like the structure of the brain case that we have this assumption of like how the green is like shaped and like how much of it is, and the yellow and the orange and the pink?
So when we have a dinosaur brain case, we can tell the shape of the brain, even if we can't necessarily tell the exact volume of the brain, because it probably wasn't, pushing against all the edges of it. There's some filler material in there too. But you can look at the overall structure of the brain of the T-Rex there, kind of in the middle, and then compare that to like the crocodilian, and they're pretty similar like that. Like, it's more similar in shape to the crocodilian's brain than it is to the crow's brain or the emu's brain. And that is not really something that was discussed much in the original paper. And that's critically important. And then the idea too that like bird brains occupy the full size of the full extent of the brain case. It's just pushing up against the edges of it. That would not have been the case for dinosaurs. Based on the shape of the brain and based on like the interior texture of the brain case, it's pretty clear that like it's not really pushing up against the edges, I guess. But also you can look at modern crocodilians, and it's the same way, where like the volume of the brain case is like 3 times the volume of the actual brain. So like using that information, some of the assumptions from the original paper already start to fall apart before we even get into some of the other stuff like variation and larger animals need more neurons to control their bodies, I guess, than smaller animals do. So like, yeah, what's your understanding of that, Balloon, actually? Because I'd love to hear it from somebody who knows more about this than I do. The bigger you are, you're going to need more neurons just by virtue of having a larger body, right? Is that a good assumption to have?
Oh, that is, I would not put a rule on that. I would not put a rule on it, because there are, again, let's go back to the ants, right?
Yeah.
That soldier ant in leafcutter ants, for example, is massive compared to a nurse ant. And yeah, you're getting some increased number of neurons, but it's not really a proportionate increase with body size. It's
So
almost
it
like
doesn't scale directly with body size.
exactly. It's like yeah, there's enough, and the way I view it is that neurons are energetically costly, right? They are firing a lot. There's glucose that takes in. There's a lot of different elements.
Sure.
Right, so if neurons are firing and they're needing all this energy, how do these neurons actually are able to communicate? And so you would want to, if you're an animal, downsize the number of neurons that you're able to have. Fewer neurons, the better. That to do a particular function. So, I think, yeah, they're bigger. They're bigger brains, but they're not like that same kind of scale that you would predict. And I think that's an element that isn't really seen here in some of these studies, like you were saying, because like the brain space too, like if it's not expanding and taking up the entire brain, I guess holding area, if you will, right?
Sure, yeah.
For because there's connective tissue, there's buffers, right, to prevent the brain from jostling that you have to take into account for. There's connective tissue. It's not always like that scaling pattern, so I think it's maybe most rudimentary method. Like, yes, a bigger body is a bigger brain, but that doesn't actually mean like it scales the same way as your body's getting bigger, and so it's
much more complicated than that. There's other complex relationships going on.
Exactly, and it's something that's illustrated in our ants, where again you're genetically identical. And you could be 5 times the size of your sister, but that doesn't mean that your brain is 5 times the size of your sister's brain. If that mathematics would actually, let me give you the raw numbers. If that mathematics was sorted out, so a nurse in a leafcutter ant caste has about 50,000 neurons.
Okay.
And the soldier, which is 6 times bigger, on average, has about 120,000 neurons. Right?
So just a little over double.
Exactly. Versus the multiplied by 6, it's not 300,000 neurons. Right? And so, yes, bigger, but not scaling with body size. And it's because there is different kinds of connective tissue, musculature, and their form function kind of question too, right? And so, again, not saying that ants are the same as dinosaurs, but in those kinds of instances, you're not seeing that scaling. And I can imagine similar situations, like you're saying too, with the brain space. Or one thing we looked at recently was kingfishers, and how much space that their brains occupy versus a woodpecker, right? Because you might, with woodpeckers,
they're
you have
both impacting a substrate, but
right. So the woodpecker's brain can't take up the entirety of the space, because it actually has its tongue wrapped around its brain, exactly, as it's pecking, and the kingfisher doesn't. Yet they're both having high impact, and it turns out that the kingfishers have a high level of a protein in the diving kingfishers that is not present in the non-diving fishers. And so the hypothesis is that the high levels of that protein are actually protective against concussions.
Very cool.
Right, and so, but
so
that,
like a belted kingfisher might have higher levels of that protein than like a kookaburra or something.
Yeah, and the genetics actually, like, there was I can send you the paper if you're interested. They looked at the phylogenetic tree, and it evened out. So everything was diving had high levels, everything that wasn't diving had low levels. They didn't prove that it was this protein, like, beyond a reasonable doubt, like experimentally, but it was very much like there was this strong correlation here. And then the brain size actually, like, took up more space in the skull of a kingfisher versus a woodpecker because of that metric. And you might, I don't know, there might be dinosaurs here that, given their life history and lifestyle, might have had impact on their skull that would need to be careful and need to have that protective something built in, and that could be taking up space. It's quite a, I don't know, I made a long explanation of nothing there, but it's, I guess, illustrating complexity.
I don't know. Yeah, like just explaining that there's a lot going on here. I think that's worth something when we're talking about a subject like this.
Yeah. But I really like this figure. I think this figure alone kind of illustrated, I think, the very strong complexity of the background to make this kind of statement of what the original paper was wanting.
Yep.
Yeah, and yeah, Tatum, similar to the woodpeckers and the paddock skull, exactly. So Tatum, like space dynamics and structure, if it's different in a dinosaur, because it could be different in a bird, right? If you make the argument that I'm going to fill up the entire space of a skull with a mathematical model for how much brain tissue is in there, that might be wrong, because you might have padding in there, you might have connective tissue in there. For an ant, you might have musculature in there. And Mook gives up the big question is the ability to gauge intelligence from brain neuron count by brain size. Can it be accurate in long extinct creatures? So that's what they're trying to do here, Moo, but account for a lot more. So the original paper, Moo, the variable was just neuron count, and that is suggested that is not enough. You have to account for a lot more variables, and it's actually variables that the variables that were ignored in the other paper and pointed out here in the rebuttal are variables that we have answers to.
Yep. They're not mysteries. They're stuff that, we can test through other means.
And have tested. My understanding is the papers are there that have already tested some of these assumptions in the original model that would have debunked it.
Yep. And that, and also the estimates in the original paper too don't seem to really make a lot of sense. When you actually explore some of these variables and you look at some of the complexity here, the estimates are way overshooting the number of neurons that these dinosaurs should have had. Because you're making bad assumptions about let's just take the bird numbers and multiply them to get the dinosaur numbers.
And I know I keep harping on it, but these estimates don't take into account glial cells. And those, if you're just looking at total cell population, those glia are going to be important. They perform different functions, and so if you're trying to gain insight to intellect as well, when you have glial cells contaminating the population, that makes it really, really difficult to make that end game hypothesis of what exactly is the behavior output from just raw cell number.
Right. Yeah. One of the things that I thought was really cool about this paper too is actually having new estimates for not just body mass, but also basically doing an EQ, an encephalization quotient, for a bunch of these different dinosaurs. It's really neat that they're that could have been a cool paper in and of itself, but it's just kind of nestled in here within this rebuttal paper. I think it kind of speaks to this idea, like I brought up earlier, that this is a paper trying to actually drive the field forward, rather than just kind of making a big claim. And there's some real interesting legwork going on here, and this paper will get cited for that reason. I'm eager to look through some of these, turning my head sideways so I can read them. But
the table has an absurd amount of information put into it, specimen number, what was collected, percentages of brain mass that would have taken out. There's a lot of info here, and I think it's almost, like you said, it's almost multiple papers kind of put into one. And it's I don't know, maybe I don't think I missed it, but they would have been great to have a really direct summary figure of all the methods. Yeah, I didn't miss it. That's good.
That would have been cool to have. You're right. Just in a visual format, it's wow, here's all the different things we did in this paper. Kind of show don't tell right there. That would have been really cool.
Because it is important for more than just the rebuttal. It's important for these graphs. It's important for even that first figure on the brain region estimation and how that could have evolved over evolutionary time. I think that's important too. And so it's there's a lot of, it's almost I envision the summary figure as it shows off kind of what we did, but it's almost a guide to how to ask this question and what data you need to better understand said question. Right, and so you move away from just the straight brain cell number, and here is this holistic approach that you need to do to really get at a question that's going to be complicated anyway. Because as Neil pointed out, what is even intelligence? Like, that's its own separate comment, right? But like, and like whole stream series even of what the heck even intelligence is. But I think it argues very nice to the point that to make these broad statements, and I would argue it applies to any behavior, not just intelligence, but you need multiple lines of data, especially on something that's extinct. And so like bringing in the experts and having that holistic approach, not just in paleontology, but in all fields of science, that collaborative atmosphere is what pushes science forward, not being insulated of like the neuron count or here is the bone, but rather pulling it all together.
Agreed. Yeah. Not this idea that like, oh, I'm so smart I can figure all this stuff out myself, and then here's my ideas about neuron count and like sole authorship. It's not how paleontology works, at least.
And then, Sam makes it even more complicated of pointing out it's not just the neuron number, but like how they're connected and what the connectomics are of it. And that, Sam, we don't understand that. We have a map in fruit flies. We do not understand it. Like, we have the map, we don't have the Garmin to read the map. Or the whatever GPS the youth are using now, Google Maps. Because it's like you can see this neuron's connected to this neuron and it has this X number of projections that interfaces with 10 other neurons. But what that actually means on a behavioral or neuronal signaling level, I've heard the argument from labs that we don't have the computer processing power to run a simulation to figure out what exactly that is.
It's pretty cool to think about, actually. Yeah.
And, I mean, that's a limitation of the human data. I've heard the argument of even if we get the slices, which is a technological feat on its own in humans, there would not be the computer to power to put all those together because it's so much data.
Yeah. That's neat to think about.
Yeah. And so it's, you have to work together. And we were talking about the comparison of the crocodilian species, and like you said, like it's a split point that's very, very much distant, but so are the birds that are being highlighted. What you do the appropriate comparisons to, it's a very hard question. And it's not at all putting down, I don't think, the first paper. I think it's just highlighting that this is not straightforward, and you need help. And like knowing when you need help from a scientific perspective, maybe it's humbling to ask, like, I need help from a different field, but I feel like it would have made the publication much better, just like many other papers, to have that interdisciplinary approach.
Yep. Shoot, that might be an excellent note to wrap up on.
We did take you for a long time today, Danny. I'm so sorry.
Yeah.
I know we took you to such a long time.
I had a lot of fun with this. I'm so glad that you were so excited about this too. And I was hoping that this would be one of those papers where we can take things that you work on and take things that I work on. We've just got that nice confluence there. This was an all-timer. This is, I think, one of our most fun conversations so far.
Yeah, and it was already so multidisciplinary that then bringing us two together, it was just like a great way of commenting on multiple different elements of the. It was, I know you were like, oh, you want to start on the worms? Like, no, I want to start on the dinosaur one because I have thoughts on this one.
Or else we'd be here for another 3 hours. Yeah.
As you know, I probably will be here another 3 hours, but
You're 3 hours ahead of me. Holy cow.
Yeah. It's only midnight. The night is young.
It's almost bedtime for me. I gotta put a pizza in the oven and got an early morning tomorrow.
Danny, truly thank you so much for all these crossovers, and this was as always a lot of fun. I really I know I said it, I cannot verbalize how much I appreciate these crossovers, your friendship, and then everything that you do for the scientific community, not just on Twitch, but I think in general, like the really nailing down the importance of science communication and making it accessible to as many people as we can. And you are, my friend, the pioneer on that.
I appreciate that more than you know, Balloon. Holy cow. I don't know what to say in response except to try and reflect some of that back to you too. The community that you fostered here, and I think it says a lot that people come in and they are unafraid to ask you just about any question. I think that's a result of kind of the environment that you've built here, and that's so cool. I cannot wait for you to get Twitch ambassador status. Congratulations again on the very, very much deserved Partner Plus. Ambassador, I think, is right around the corner, and I'm excited to see what you're going to continue to do here.
Thank you, my friend.
And I'm proud to share this platform with you, so thank you for the opportunity.
One thing that I would love to do if we could ever get to that ambassador check is to form a guild of the of like the educators, and because like I think the guilds have really taken off so huge, and that would be like that, and they do meetups in different cons, not just TwitchCon, but a lot of places, and to get guild members to scientific conferences and have a platform sessions on science communication like this. Like I'm already, I don't stop thinking at a goal. I've got 10 goals ahead of it. I'm like, I can see this as we being on the precipice of a SciComm revolution.
I love that idea. I love the way you're thinking about it. I am excited to follow you into that. Holy cow.
You're a besto friendo, Danny. Thank you again. Is there anything that we can promote? I do have the Dinosaur Campaign email as well as the wish list pinned to the top of the chat. I know we've got Thursday Birds Day coming up tomorrow.
And it's also World Tuatara Day tomorrow. We'll be talking about this really cool group of reptiles that are not lizards, even though they look lizardy. We'll be talking about why they're not, and they're a group of reptiles that was super diverse back in the age of dinosaurs. Now there's only one species in the entire world that lives in New Zealand, and people are going to fall in love with this animal tomorrow.
It is beautiful. So cool. It's a beautiful animal too, and I think you did one last year too, and or maybe even 2 years ago.
I didn't know about World Tuatara. We were just talking about Tuatara as a matter of course. Like, it came up somewhere, and I was just gushing about them. We've got a whole day tomorrow to celebrate.
Hey, that's where I learned about them. So, chat, you can learn about so many cool things on Danny's stream. Please go drop him that follow. You know it. In the episode description, we just did the fancy shout. I will do another one in an hour because that's what we do here. And there's the wish list behind us, and Danny's going to be doing field work soon, so y'all make sure to be there. That is, I'm telling you, people are going to be falling in love with science all over again.
I'm excited for it. It's such a privilege to be able to do this, and thank you for helping out with that, Belinda. I really
always. Thank you for letting us be part of it.
All right. I had a great time tonight, Belinda. And hopefully, I don't know about next week. We'll have to see. I might have some other stuff going on, but let's shoot for doing another Wednesday night crossover, even if I can't guarantee that I can make it.
And then soon after that, just so you know and chat knows, we're traveling down to Florida for my sister's graduation from med school. And so we're going to be doing some IRL streaming down south. But I don't know if you're game, please, don't decide now, but it would be harder. I don't have the production value down there of this. We just have the IRL. But if you wanted to do a crossover on your channel at some point, I'd be, it doesn't even have to be a Wednesday. You can just tell me, here's the day that I'd be interested in, and I'd be happy to do something similar like this before you go to do field work, because I assume from the field this will be very difficult to do.
Yeah, shoot, and then with the time difference and everything else, and it gets, I don't, it would be dark outside. We wouldn't have any light, so to do it by campfire or something.
the warm cozy, we'd have the whole animation going with like.
And I wouldn't be able to hear you either. That's the thing, is that I don't have audio set up out there, so we'd have to have a phone call at the same time or something.
Yeah, well, we'll figure it out. I just, we'll have something planned up.
Sounds good. Right,
Thank you, Danny. Have a good night.
Take care, everybody. Bye-bye.
Guys, that was the amazing, as always, Professor Danny Anduza. Please, if you ever have the chance, go thank him on his stream for these crossovers, because they are one of the most amount of fun that I have.